So am I audible and visible to all of you or not? It's just to let me know in the chat section. This is your Baba HSP. I would like to see that if I'm perfectly audible as well as visible. I want to see green hearts. This is your Baba HSP over here. Yes, I can see Pooja, Sai Chiranjeevi, Medha as I can see over here. The green hearts. So I'm perfectly audible. My voice, Sahana, welcome. Welcome, vanakkam, suswagatam. Those who are thinking that chemistry Prikyaradu customer, I would like to say let's from Sulbam. The things which are looking Idiyappam Murku, they will become Sulbam. What I said in Tamil, that's if you're thinking that if you are having those things like in your mind that organic chemistry is stuff of class 12. I want to say no, 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 not at all. Ella means no. The things which are looking very tough, confusing, they will get solved easily, easily. You will be able to understand. But how's the Josh? If the Josh is very high, I would like to see fire in the chat section, everyone. Now, what I will do over here. So fire, 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 everyone, everyone, let me check it out, let me check it out, fire, I want to see fire in the chat section. What's going on, kids? What's going on? Fire, make it. That's really awesome. Now, kids, today I will move with speed, but with accuracy. My target will be to move chapter wise, NCERT chapter wise, and I will try to frame out new questions. What are the questions they have been asked in your examination? Those questions also you will get. But my target is, this time very tough paper maker because, last year 720 on 720 number students they have got, right? So this time I'm thinking that yes, examiner can give some tough questions, but those tough questions will be based on NCERT lines only. If I talk about the first rank, Kanishka Yadav, my student, Mehak Arora, third rank at that time, AIMS was taking separate examination, third rank, Chaitanya Mittal. That means this batch people, they are having so much potential, so good content and the expected content directly whatever the questions which I will teach today, directly questions like that or exact questions may come in your examination. So you can say it's a neat replica. So you have to make one promise to your HSP. And if you can make that promise, then only try to make it. I'm not going to take too much time. I will try to finish it just because I'm having that pedagogy in my mind. I have done a lot of homework so that I can give you the things which direct questions. I will teach, I will give question. I will teach, I will give question expected in your examination. But what promise I want from your side, if you can make that promise, then only you have to show green heart and fire. Green heart and fire, that promise I want from your side, that you will give answers to all the questions. If your answer is correct, you will show green hearts, and if it is wrong, you have to show fire. And for that, you have to sit, you have to understand. I will go according to NCERT chapters. If you can make that promise, green heart plus fire, I want to see then only, not only. Audio not clear. Who is this audio? Oh, number of students. Let me check it out. Let me check it out. Just wait. Just wait. Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Now check it. Now check. Now do let me know what's the quality of audio, kids. Everyone, just to let me know in the chat section. Now the audio is, yeah, I will teach from the basics. No voice issue. Kids, first of all, do let me know. Some kids have written that audio is not clear. First of all, do let me know in the chat section. If audio is perfect, only green hearts. If audio is perfect, then only green hearts I want to see. I think some people are spamming. Spammers are there, or really uh, there is problem with the audio. If no problem, everything is perfect. Yes, clear. Just show me everyone green hearts if audio is perfect. If audio, yeah, that's perfect. Okay, audio is perfect. Thank you, thank you. So let me start. Let's set go, kids. Hello, alkanes and haloarenes. This chapter I would like to categorize in two parts. First part, how to find out whether the reaction is substitution, elimination, and in substitution it is SN1, SN2, E2. That is the prime function. If once we are able to clear this, that means the backbone of this chapter we have completed. Okay, and then I will tell you how the preparation of haloalkanes and alkyl halides and then their chemical properties. So I'm going to divide it into two parts. What are these two parts? First, substitution versus elimination. This is the backbone of this chapter. This is the backbone of this chapter. Then what is left? Preparation and chemical properties. All right, two things. First, how to find out whether the reaction is substitution or elimination. And just to find out whether it is substitution or elimination, we have to focus on one thing. That, what's that? That thing is, if an entity is having, suppose if an entity, let me write down with X negative, this X negative, just to find out whether the type of reaction. First, I will give you trick, one trick and then in detail. Remember, one trick and then in detail, right? But just before giving you the trick, diamond trick, let me ask one question. This X is having negative charge. Charge is like a disease. Remember that. Charge is like disease. So everybody would like to get freedom of that disease. Not just to get freedom, if this is going and getting combined with this carbon, going to combine with carbon, everyone will say you have done the role of nucleophile, acting as nucleophile. And if it is going to form a bond with proton H plus, then everyone will say that yes, you're combining with this proton, so you're acting as a base. Acting as base. So remember that if it is acting as a nucleophile, it will be responsible for S and SR, and it can give two type of things, SN1 or SN2 like that. Okay, substitution. So ether, generally ether, that will be Williamson synthesis of ether. And if it is reacting with proton or snatching proton, then it will give elimination, and elimination will give alkene. Alkene. So in most of the reaction, it plays both the two roles. So parallel reactions, right? I'm starting from here. No teacher is going to start from this place. Now, one thing I've told you, so simultaneously it will try to act as nucleophile as well as base. Clear? Clear? This much is clear. Now, this nucleophile or base is responsible for both the two reactions. And when the teacher is teaching this chapter, sometimes that teacher is telling you substitution, then teacher is not telling you elimination, but simultaneously elimination was also taking place. And if teacher is teaching once the elimination, that teacher is not going to tell you elimination, but the examiner will give you the question where you have to give both the answers, and that's why you are getting failed. So whenever I'm going to start SN2 reaction, I will put the heading SN2 and I will tell you about SN2. But by chance, if E2 is also taking place, I can't tell you at the same time. Why? Because if I'm telling you both the two things, people will not be able to understand. But just before starting SN2, SN1, E2, even I would like to tell you, just by simply seeing the reactant, you can find out what type of reaction is going on. Are you ready? Are you getting my point? You should have in your brain, just like when you see a movie, class second student was going to his school. Neighborhood, one girl was also going to class and she was also in class second. Once, boy has given chocolate. Now 16 years later, the movie is showing that heroine is coming with car. That means what? If they're just showing you for 10 minutes about, they are giving each and everything about heroine, at the back of your mind, it must be going on what happened to that hero. He must have grown up. So like that, once I'm teaching in the SN2 reaction, whatever the thing, it should move on whether E2 is also taking place or not. Once I'm telling you about E1, you should think about whether SN1 is also taking place or not. Once if you are having this knowledge, you can do anything. Once you are going to find out SN2, then I will tell you it is second order kinetic, single step reaction, no rearrangement. SN1, multi-step reaction, complex, so rearrangement may take place. Are you getting my point? All these things you can find out only once if it is in your brain, that by simply seeing the reaction whether SN2, SN1, SN2, E2 both or only SN2. Ready? Let me see in the chat section. Are you having this much of patience? Just in 20 minutes, I will teach to each and everyone by simply seeing the reaction. You can find out whether SN2, E2, SN1 even. Let me see in the chats. Let me see in the chats what people are saying. Yes. Voice is not clear. It's some are saying clear, some are saying not clear. What is this? Okay, just wait. Just give me time. Just give me a second, kids. Let me call somebody. Wait, kids. Wait, wait, wait. रामलाल जी आप सेंटर पे हो? अरे ये कोई होगा जो आवाज इसकी माइक की मैं हूँ। हाँ हाँ। हाँ हाँ भेज दीजिए। ठीक। ये आवाज जरा चेक करना, इसकी आवाज बोल रहे हैं कि रोबोट की आवाज आ रही है। इस पे इस कैमरे पे नहीं है ना? आप इसमें देख लीजिए क्या दिक्कत है आवाज का। आवाज रोबोट की तरह बोल रही है, इसमें देख लो कहाँ पे गड़बड़ हुई। इस पे चल रहा है एबीएस पे, ये एबीएस चल रहा है, ये देखो इसमें। अच्छा
हेलो रामलाल जी, इशू आ रहा है रोबोटिक के जरिए।
हेलो हेलो हेलो।
लैपटॉप के सामने बैठे हैं।
हाँ ये बैठ जाओ आप। हाँ बोलो क्या लगाए,
साउंड बार लगा होगा ना?
क्या लगाए?
हेलो रामलाल जी, रामलाल जी, हेलो, साउंड बार निकालना पहले। ऑडियो
हेलो हेलो हेलो।
बताओ, ये देखो।
अब देखो ये जस्ट सामने लाइन आ रही है ना, इसके यहाँ पे लेफ्ट साइड में हो। यहाँ ये ऊपर वाला देखो, लॉक पे क्लिक करो।
लॉक पे ऊपर वाला,
हाँ
ये लॉक वॉल्यूम पे।
नहीं नहीं, लॉक नहीं, इस पे क्लिक करो, डबल टैप करो लॉक पे इस पे, इधर 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 खुलने वाले पे।
हाँ, ये जो लॉक ओपन है इस पे।
अच्छा
हाँ ये, हाँ इस पे डबल क्लिक कीजिए।
हम्म,
अब ये करो नीचे, तो इसमें एरो के निशान पे दबाओ, एरो के
अच्छा
डबल
ओके,
एरो, डबल एरो।
डन।
अब इसमें बीच वाला करो।
ठीक है,
अब ओके, इसमें चेक मार करो, चेक मार।
अब ओके,
अब ओके करो, ओके ओके ओके।
डन।
अब आप चेक करो, सर को साउंड चेक करा दीजिए।
एक बार साउंड चेक करना।
kids now check, now do let me know kids everyone, now let me know kids, now let me know, now kids let me know, now the audio quality kids, hello now fine, thank you रामलाल जी को भी थैंक यू बोला। या किड्स सी, थैंक यू रियली, थैंक्स किड्स। Thank you kids for the patience. Thank you kids, really thanks. Now kids, I will try to deal this each and everything through questions, right? We will move through basics along with questions, right? So very good kids. Everyone show me green hearts. Once finally show me the green heart. Thank you Murugan. I have tried all the efforts just to make it clear kids. It's our what to say win-win position. So never give up. What we understand from this episode, never give up, right? Now, never give up. Now everything is clear kids. Very good. Camera is slightly tilted. Let me check. Camera. Okay, let me check. Just wait. Yeah. So let me fix this also. Wait. Let me fix this also. Wait. Now I think camera angle is also correct. Just check it out kids. Everyone just check it out. Camera angle is also perfect. Everyone. Everything is clear. Just to let me know so that I can start the class. Everyone. Now the camera angle, the audio, everything is perfect. All done. So yeah. Thank you kids. Thank you. Okay, so let's go. Substitution versus elimination. Then only you can do the questions. First try to understand. Then otherwise you won't be able to do questions, right? Everyone ready? Substitution versus elimination. So I'm going to start it. See. Just see the story, even without telling you number of things, I will make it clear, right? See, type of RX, alkyl halide, where X should not be equal to fluorine. X can be chlorine, bromine, iodine. So I am writing first is 1 degree alkyl halide, RX 1 degree. Second, I am writing allyl halide, allyl or benzyl halide. So all they are being 1 degree. All of them, they are being 1 degree kids. 1 degree alkyl halide. Second is secondary halide. How to find out secondary halide? The carbon which is attached to halogen, this can be anything. X can be chloride, bromide, iodide, delta negative, delta positive. This is 2 degree because this carbon is finally divided with 2 carbons. Now 3 degree alkyl halide. Let me write down 3 degree alkyl halide. How to find out anyone is being 3 degree alkyl halide? Just try to find out delta negative and delta positive. The carbon which is being polar must be attached with 3 carbons. Will you understand? A, B, C. 1 degree, 2 degree, 3 degree. The story of doctor and patients. The story of doctor and patient, right? So these are the type of alkyl halide. Now let's see the type of reaction, reaction type, SN2, E2, SN1, E1. What's common in between SN2 and E2? The common point is that they do reaction in single step reaction. Both are single step reaction. What's the common point in between SN1 and E1? Common point is that multiple step reaction. Now just see what are the likings. These are the type of reaction. You can say these are the patients and these are the doctors. Doctor having 1 degree, doctor having 2 degree, and doctor with 3 degrees. Now what type of process they want to do? This Rx will always do SN2. Why? I will tell you the logic. I will tell you the science behind it. Now rest of all others, they want to get treatment with this 3 degree. They want to get treatment with 3 degree. Now the management decided no doctor can treat more than 2 type of patients. Now this 2 degree is having equal tendency to show all type of reactions. This 2 degree has got tendency to show all 4 types of reactions, see, but broken. So management, what management is saying, no doctor can treat more than 2 patients, but this doctor wants to treat all 4 type of patients. Now who will decide that which type of reaction will take place? Then here comes the type of nucleophile oblique base. These are of 2 types. Just see, one is strong. How to find out anything is strong? RO negative, or it should be given as RONA, or can be given as ROK. That in between RO and Na there should be ionic bond. They are indication of strong. How to find out it is weak? Or poor? Weak or poor means ROH. O is attached with hydrogen, covalent bond. There it was ionic bond. In between O and Na, ionic bond. And here is covalent bond. Can you see covalent bond? So ROH is weak, HOH is poor. Now this type of management wants, this type of entity wants that reaction should undergo this type, that single step, because they are strong and this is single step. So single step reaction SN2E2, and this poor management or weak, they want to show SN1 even, either SN1 even, they are their liking. This is the story. I think I have taken just 7 minutes in this. Now just to let me know this story is clear, then you can answer all the questions. Just to let me know in the chat section the story is clear to all of you. Everyone, I want to see in the chat section. This story is clear. What type of management, what type of doctor, what type of patients are there? Everyone, I want to see in the chat section. Okay. So once this is clear, then you can answer all the questions. Tally is, let me write down, tally is T.me HSPN T.me/HSPN. Okay, T.me/HSPN. Now let's answer the questions. Question: find out the type of reaction or reactions, right? Type of reaction or reactions. Okay, are you ready, everyone? Are you ready? Now see, if you are able to answer these questions, you can do anything. You can do anything. Just see, kids. You can change the whole world. See, question number 1. First, CH3, CHCl, CH3. What type of alkyl halide? So definitely you can find out this is 2-degree alkyl halide, because the one who is having this positive charge is attached with 2 more carbons. So its degree is 2 degree. 2-degree alkyl halide. It is what? It is secondary alkyl halide. You can say secondary alkyl halide. Or you can say what? It's 2-degree alkyl halide. 2 degree. The degree is 2. Now see, 2-degree alkyl halide wants to show what type of reaction? 2-degree alkyl halide. 2-degree alkyl halide is having equal tendency to show all 4 type of reaction. I will tell you the detail. I will tell you these things in detail. Right now I am telling just the story, but I will give you the detailed mechanism. Don't worry, I will give you the detailed mechanism. So it wants to undergo all 4 type of reaction, but see, if I'm writing over here C2H5ONA, what type of nucleophile base it is? In between O and Na there is ionic bond, so it is a strong nucleophile as well as base. In the starting I have told you it is having tendency to act as base as well as nucleophile. So just see, strong nucleophile says what type of reaction it will show. If you are able to get it, just to let me know in the chat section. Just to let me know in the chat section. I want to see the answer. Strong will say what type of reaction, strong nucleophile. So I want to see in the chat section. If you are not answering it properly, I am not going to teach. SN2 and E2. Very good, very good. You made my day. You made my day. That means it will show both type of reactions. Both type of reactions. So answer is SN2 as well as E2. Why I have written E2 this much? Because major is E2 and minor is SN2. My dear students, maximum students, they are having thought process. Whenever temperature is given, then only elimination is major. But remember that it's clearly written in your NCERT. If no temperature is given, then also E2 is major. Maximum students are failing in this type, because they are always thinking temperature. Temperature increases the elimination product. If suppose if I say at room temperature, it is giving 60% this E2 and 40% this. Due to E2, it will form alkene. Due to elimination, it will form alkene, and due to substitution, it will form ether. Now what I am saying, at room temperature, if it is giving 60% alkene and 40% ether, then if you increase the temperature, then elimination amount will increase from 60 to 65 or 70, and the substitution will decrease. That's why if you want to get good yield of ether, then low temperature is good. That is from thermodynamics. I will tell you in detail. But yeah, remember that when no temperature is given, always secondary alkyl halide will give alkene as major product. Alkene as major product. Remember that. Maximum students failing over here. Students, this point is clear. Is this point clear? Now second question. Let me move towards the second question. Second question, just see. CH3, CHCl, CH3. This is isopropyl chloride. Remember the name also, because sometimes they will give you the names. Isopropyl chloride. Isopropyl chloride is 2-degree alkyl halide, and suppose they have given C2H5OH, C2H5OH. Now, if you remember that memory chart, what the mind map I have given, just let me show you that mind map. You can easily recall it. 2-degree alkyl halide. This is 2-degree alkyl halide. equal tendency for all four, but the management, this is weak or poor. So what type of reaction? Once again, I would like to see your response. If your response is not good, not correct, then what's the use to teach you? 5. Fantastic. Let's see the answer. Let's see the answer, kids. First, SN1 even. Congratulations. Congratulations. SN1 even. Very good. Fantastic. SN1 E1. Now, third question. But before moving towards third question, if you have seen this first and if you have seen this second, what knowledge you are getting? What knowledge you are getting? The knowledge point is that most important I would like to say the most important thing is that what you have got, what knowledge you have got from here, what knowledge you have accumulated from here, that secondary alkyl halide always shows parallel reactions irrespective of nucleophile oblique base. So what I want to say, if the nucleophile oblique base is strong, then it will show SN2 and E2, and if it is being weak or poor, then it will always show SN1 and E1, right? But always elimination versus substitution whenever secondary alkyl halide is there. This point is clear, everyone? Once things are getting clear to your hippocampus, keep on showing green hearts, that because from distance I cannot see anything what's written, I can just see your response. Once your response is there, then only you can get something. Yes, get everyone. Now another question. Third question. CH3 Cl CH3 C2H5ONA. Now this is known as tertiary butyl chloride, that is known as sodium ethoxide. Now what type of reaction? I will not show you that slide. What type of reaction? Let me check it out. What type of reaction? How many of you can give the correct answer? Let me check it out. What type of reaction? The bold, absolutely clear. I'm getting clear answer. Very good. Only few students are giving wrong answer. Rest of the others are giving correct answer. Only E2. Answer is only E2. Only E2 means only alkene. Only alkene means no ether. No ether means that side. If you are having knowledge, Williamson synthesis of ether. Williamson said, if you want to prepare ether, never take 3-degree alkyl halide. If you want to prepare ether, never take tertiary alkyl halide. That's the Williamson synthesis. Now, question number 4. I hope that everyone is able to understand. Question number 4. If I take tertiary butyl chloride plus water or ethyl alcohol, then definitely the answer you know very well, SN1 and E1. Now if I take, this is clear, if I take question number 5, if I take CH3 CH2 Cl plus CH3 CH2ONA. Now see, let me check what answer you are going to give this for this sodium ethoxide and ethyl chloride. I want to see your answer. Ethyl chloride sodium ethoxide, sodium ethoxide. Yes, everyone, this is very, very important, and this is only Williamson's synthesis of ether. Williamson's synthesis of ether. I would like to see the answer in the chat. Now, SN2 only. Always write down only SN2, only SN2, only SN2 means the best yield of ether. SN2 only, that means only ether, and that's why Williamson said if you want to prepare ether, always take 1 degree alkyl halide, least sterically hindered alkyl halide. Everyone, are you enjoying? So the question of your NEET examination or IIT examination, question asked was which will give best yield of ether, which will give best yield of ether. So first, A, tertiary butyl chloride CH3 whole thrice C Cl plus CH3 CH2 ONA. Second is B1 is CH3 CH2 I plus CH3 CH2 ONA. Third one is C1 is isopropyl chloride plus same reagent C2H5ONA. Now, out of these three, can you tell me what's your answer or what is the order? Can you arrange in the order? And dry ether is there because polar aprotic solvent is used. PAS is polar aprotic solvent. That can be anything like dry ether. Okay, let me check it out in decreasing order. Otherwise, it has given which will give best yield of ether. I want to see your answer. Everyone, I would like to see your answer. Keep on showing me the answer. Once I open it, there should be the answer. Wow, very good. BCA. Wow, my dear students, you are rocking. That this is 1 degree. This is being 1 degree alkyl halide. This is being 3 degree alkyl halide, and this is being 2 degrees. So answer is B, then C, then A. Right, fantastic, awesome. Now see, I'm going to give you second question. Here majority of the students will get failed. Majority, are you accepting the challenge? Just see the challenge question. Five-membered ring is there. Let me check it out. What answer? I will give you the options also. Option A, option B, option C, option D, option E, these are the 5 options for this question. These are the 5 options. Just see to it. And once I am going to open the chat, I would like to see your answer. If you are really intelligent, you have to answer this question. Okay. Have you seen? Okay, let's see how many of you can answer it. Let me check it out. So what's your answer? So maximum students are going for C. And kids, let me tell you this answer. This answer is absolutely wrong. This answer is absolutely wrong. Ask me why. You will get 0 marks. You are going to get 0 marks for this. Absolutely wrong, kids. Ask me why. Just please ask me why. Ask me why. What's the reason? What's the reason you are going to get 0 marks? Now, let me show you, kids. Let me show you. Let me show you. And this is the thing. That's why this channel is not only teaching you, this channel is making you error-free. What is the degree of this alkyl halide? What's the degree of this alkyl halide? 2 degree alkyl halide, because it is attached with 2 carbons, the carbon having del plus 2 degree alkyl halide. And what is this? Nucleophile oblique base, strong. Strong. What I taught you, kids, what I taught you. Just see the slides, just to let me know from this what you got it. If 2 degree alkyl halide and the management is being strong, it will give you what? SN2E2. And SN2E2 are single step reaction, and single step reaction will not proceed with the formation of intermediate. No intermediate. No intermediate means no rearrangement, no ring expansion. Let me write down if you're not able to understand. SN2E2 means follows second order kinetics. Second order kinetics, gets right. Second order kinetics, single step reaction. Single step reaction. Then how the rearrangement? No rearrangement. Single step reaction means no rearrangement. No rearrangement means no ring expansion. No ring expansion. No ring expansion. Now you got what mistake you have done, kids. Have you got it? SN1 E1 follows first order kinetics. First order. That's why first order kinetics. First order kinetics. Now moves through intermediate formation. Intermediate formation. That means what? Rearrangement may take place. Not necessary, but rearrangement may take place. Rearrangement may take place. And SN2 always follow 100% backside attack. 100% backside attack. On backside attack means what? Inversion of configuration. Inversion of configuration. And inversion of configuration in case of chiral, when the carbon is chiral, then it is known as Walden inversion. Walden inversion. Walden inversion. Now whenever it is SN1, both side attack, but backside is dominating. Backside dominates. Front side is minor one. Front side is minor one, right? I hope everyone got it what I was telling you. So let me move to the question that majority of the students got failed. Now, once I have told you all these things, now tell me the answer. I have given you the data. These many things I have told you. Now I want to see the answer in the chats. Kids, do let me know what's the answer. Now I want to see the answer. See this question once again. Majority of students, 90% students got failed over here. 90% students failed in this question. Failed. That's why I'm telling you again. Now let me see. Wow. Thank you. Kids. Yeah. Backside attack. in 3 degree can't take place. I will tell you. Now show me the green hearts if you're really liking it. If you're really liking it, enjoying it. So it is moving from north. This is moving from north. This is north side, up side, north, or you can say up. So the incoming nucleophile will come from that side, back side attack. So D is the correct answer. 100% D is the correct answer. Got it, kids? Everyone got it? Got it or not? Really got it? Now, one more question where majority of the students will get failed. Majority of the students are going to get failed. See. Let me give you options. ET. For ethyl we can also write, the examiner can also write ET, ethyl, for ET, ethyl. OET. 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 Nota, none of the above. None of the above. Just see this question and then I will come back at the same position to check it out. What's your answer? Right now I am framing out new questions. ET means ethyl. ET can be written. And for methyl, ME can be written. ME. Just see the options. I hope that everyone, this is frequently asked question and I would like to say it is anaconda question because maximum students will get failed over here. Maximum students are going to get failed. So let me check it out. What's the correct answer you people are saying? See, you can see in the chat. Maximum people are getting failed. All the options they have clicked. D, C, A, all these things. Now see kids, what should be the correct answer? Now those who have got the answer, they will get like this. Now, why people are getting failed? Let me tell you, there are two reasons why people are getting failed over here. First reason, they will see this axis. They will see this axis is written and this axis is saying that this answer should be correct. This axis is written, this answer is correct. Now some of you must be thinking that leaving group tendency is iodide, then bromide, then chloride and then fluoride. Some of you will get trapped because of it. So they are thinking bromide is good leaving group. So never do like that. Just what is the position where they are being located? It majority concept. If you don't know most of the concept, if you are getting failed over there, you can't do anything. If they both are located on sp3 hybridized carbon, then this is the leaving group tendency. If everyone is located on sp3, but if the hybridization is getting changed, see, its lone pair is doing resonance because it is sp2 hybridized, and its lone pair can't do resonance because it is sp3 hybridized. Due to resonance lone pair, the single bond will develop partial double bond character. The single bond will develop what? Partial double bond character. It is having partial double bond character, and due to this, its bond length will decrease by 8 picometer, so it will not leave, and people call it vinylic atom. Remember that people call it vinylic atom. It is vinylic, and vinylic will never participate. Vinylic will never, and this is being allylic, will leave easily. So this is the answer. Everyone satisfied? If everyone's satisfied with my hard work, I want to see green hearts. Let me check it. If you're really liking it, kids, I want to see green hearts. If really I am doing a hard work, if really I am giving you good questions, real questions, on the spot I am making questions. Let me see in the chats that people are really liking it or not, kids. I want to see in the chats. Very good, very good. Speak Tamil. Medhuva, you will be able to understand. And chemistry, pidikya? Radu customer, if you're thinking like that, it's Filicum, Romba Sulvam. It's not a Deba Murikyo. I will tell you it's Romba Sulvam, right? Now, kids, very good. Before I move ahead, I want to share something. I would like to share something with you, kids. Then I will move ahead. Kids, you know, Unacademy unlock the champion in you. Flat 60% off. Kids, even you can benefit it. You can help your brother, sister, relatives, your classmates. 60% off if you apply code HSP10. HSP10. It will be available just for rupees 4,499. See, and offer ends tomorrow, kids. So remember this. Tell it to everyone. You can help them right now. Euphoria. Spin and win crazy rewards, win smartwatch, laptop, test series. Oh my god, really, it's awesome. Notes and 4.0 and more. 8 April, 20th April spin now, right? Now, what's new? Oh, 10 free mock tests before actual exam. This is really good for you kids. 10 free mock tests before actual exams. Your gateway to NEET 2025 success and number of things. 13 April. 2 to 5 p.m. Now, you know, Vasin sir, and this is Join NCERT Crux test series for NEET UG kids, right? It's really awesome. And test flow is like this. You can see and you can go through it later on. And, you know, this is one batch where these 3 teachers, the best, you know, ma'am. And yeah, this is one more team, kids, you know very well. All the teachers, the best teachers. And once again, this is for Nexus class 12. That was for class 11th. And this, once again, join Phoenix batch class 12. The best teachers, combination of teachers and the best teachers. And we teachers, we know very well all the teachers. Now, let me come back to our flow. Flow, where it's gone. Yeah, we were over here, right? It was a short break for you and you have seen number of things. Kids, should I move ahead? Everyone, are you ready for the next things? Are you ready, kids? Now, let me first of all give you one mind map so that all the reactions should become very simple. So, are you ready for the mind map? From this mind map, you will get 4 to 5 questions. How many questions? 4 to 5 questions. Really, I mean it, kids. How many? 4 to 5 questions. That means at least 20-25 marks. Are you ready? I want to see some fire in the chat section if you're ready. 20 marks mind map. 20 marks. 20 marks mind map I am going to give you, kids. At least 20 marks. Now, see the mind map. Benzene, And if you do the nitration, what will you get? From benzene, what will you get if you do the nitration, kids? Do let me know. If you do the nitration with benzene, what will you get? Everyone, I want to see the answer in the chat. If you do nitration, then we will get nitrobenzene. Now, nitrobenzene's reduction, if you are doing the reduction of nitrobenzene, what you are going to get, kids? Do let me know. Nitrobenzene's reduction. Tell me in the chats. Nitrobenzene's reduction with tin or iron plus HCl, you will get aniline. Try to keep it in your brain, then I will give questions also. You will get aniline. Now kids, aniline's diazotization, you know how will you carry out diazotization? Anyone from the public side? Diazotization, how to do the diazotization? For that, NaNO2 HCl both together will produce HNO2, and this HNO2 is unstable. This will break down to produce nitrozonium, and what do you call it? Nitrozonium ion, and this reaction is carried out in ice cold solution. By ice cold solution, kids, ice cold solution to maintain temperature 0 to 5 degrees Celsius. Then you will get benzene diazonium chloride, because it is stable only at up to 5 degrees Celsius, 0 to 5 degrees Celsius. What's its name? Benzene diazonium chloride. Till now it's okay, kids. Till now it's gone to your brain. Now from benzene diazonium, till now it's okay. Is it visible? Do let me know in the chats. Till now, is it visible or not? Benzene nitration. How will you carry out nitration? Concentrated HNO3 plus concentrated H2SO4, concentrated HNO3, concentrated H2SO4. First nitration, then reduction. This is reduction. You got aniline, then diazotization, aromatic, only aromatic primary amines undergoes diazotization. Till now it's okay. Do let me know in the chat. Keep on showing green hearts if it is okay, if it is clear. Kids, you are very stingy in writing, in showing emojis. Now benzene diazonium chloride, kids. Benzene diazonium chloride, if you react this benzene diazonium chloride with HbF4, remember that, with whom? HbF4. HbF4, what will you get? Benzene diazonium fluoroborate, N2BF4, benzene diazonium fluoroborate. Now, in old NCERT, very old NCERT, page number 398, right hand side at the top, 3.5 right lines are written. And if you talk about new NCERT, then page number 406, right hand side top, 3.5 lines are written. 4 to 5 times direct questions has been asked from those lines. That benzene diazonium chloride is unstable at room temperature and readily soluble in water, whereas benzene diazonium fluoroborate is not soluble in water at room temperature. It is stable at room temperature. Its name is benzene diazonium fluoroborate. Just check it out if you are having NCERT. Benzene diazonium fluoroborate. First of all, let me see whether you are listening what I am saying or not. Let me check it out. Kids, show me green hearts if you are really listening. If you are really listening, you are able to get it. I want to see. Okay, write down something, kids. I'm really working hard or not, or just wasting time. Write down something. I want to see that really I'm working hard. I'm giving you new questions. I should move like this. I'm giving you questions. I'm telling you the theory behind it. I'm framing out new questions from NCERT. I'm giving you mind map also. How you are feeling, just to let me know. I'm really doing hard work or not. I want to see in the chats. Don't talk about break. I will give you whenever there's time. I will really give you that break. Right now it's a time to gain something. Yes. Wow, thank you everyone. Thank you. Really thanks. Salute. Dhanyavad Alu. Dhanyavad. Thank you. Thank you everyone. Thank you. Wow, very good. Now, so it's moving like this. Okay, it's moving like this. Now it's looking little bit confusing, looking like idiyappam murukku, right? So should I change the format? Should I change? I'm thinking it's moving here and there. It's not looking good. Wait. Some kids might get confused. And one more thing, you have to help me. I'm writing it for the second time, but why I'm writing? I'm smart. You have to become smart. Now you have to tell me the first compound which I have written, just to let me know from where I have started. Everyone, just to let me know. Everyone, just to let me know what was the first compound. I want to see the revision also. So I have started with benzene. Then what I have done with benzene? I have done nitration of benzene. How should I carry out nitration? What should I add? I will add concentrated HNO3 plus concentrated H2SO4. What they together will react and give? They will give actual attacking agent. Its name is, hey everyone, it is known as nitronium ion. This time I have given something extra. Or not? Yes sir, my dear sir, really sir. We have got this compound. Hey, what's the name of this compound? So it is known as nitrobenzene. Oh my dear students, really? Yes sir, nitrobenzene. Now kids, what I have done with nitrobenzene? Sir, you have done reduction. Yes, with which reagent reduction has been carried out. So I have to forgotten. Hey kids, naughty kids, that was any reactive element which lies above hydrogen in the electrochemical series: tin or iron and HCl. Oh my god, yes. Then what we will get? So we will get aniline. Yes kids. Now do let me know with aniline. I have written number of things. What I have done, kids, do let me know. Sir, you turn the diazotization. Yes, with which reagent? So NaNO2 dilute HCl, they produced nitrous acid, because nitrous acid is unstable at room temperature, just like if you mix water to your rice. Now you cannot keep the water mixed with rice for longer period of time. So dry ice are stable, so they will become unstable. So this is unstable. So it is produced in C2. C2 means whenever it is required, and this will convert into nitrozonium. And remember that that was nitronium ion, and its name is nitrozonium ion. I hope that you can see. Let me write down properly, otherwise you will get confused. Nitrosonium ion. What is the extra? There was nitronium here, so is extra nitrozonium ion. So this reaction is carried out in ice cold solution. Ice cold solution. So what you will get, kids? What you will get? So I will get BDC, benzene diazonium chloride. Benzene diazonium chloride. Till now I made it from here, and now see benzene diazonium chloride. What I have done with benzene diazonium chloride? I have reacted it with BF4. So I have got benzene diazonium fluoroborate. Till now I told you the whole story. Once again I have told you, kids, I have done a real work, and this is looking better than before. First of all, do let me know, I will complete it, but this is looking better than before. So change chats into all chats visible. Oh my god. Oh, the bold. Sir, you are making fun and so interesting. Really? Really? Really, it has become interesting. Really, it has become interesting. Really, kids? Really? Just to let me know. Really, it's working. Wow. HBF4. Let me check it out. HBF4. Yes. Otherwise, BF4 negative. I can write BF4 negative or HBF4. You are right. 100%. 100% correct. And thank you. Now it is stable at room temperature. Now see, if I heat it, then I will get fluorobenzene. What I will get? Fluorobenzene. What should be the name of this reaction? Well-known reaction. This reaction will be known as, yes, Ball-Tiemann reaction. It will be known as she has become man. Ball-Tiemann. By removing here, Ball-Tiemann reaction. She has become man. And simply if I heat it, I will get fluorobenzene. And now just remember what I am going to do. If I react it with copper and NaNO2 and then heat it, then I will get nitrobenzene. Now kids, this benzene diazonium chloride is really awesome, superb. Just see why it is superb, kids. If I react this benzene diazonium chloride with Cu2Cl2 cuprous chloride, just see it is written in this way, Cu2Cl2 HCl, I will get chlorobenzene, the good yield of chlorobenzene, good yield. So this reaction's name is Sandmeyer reaction. But if the same thing, if I carry out with its copper powder, remember that copper powder HCl, then I will get chlorobenzene, but the yield is poor. Gattermann reaction. Gattermann, the man in the gutter giving poor yield. I will get poor yield. Now if I carry out reaction of benzene diazonium chloride with SnCl2HCl, what? SnCl2HCl, SnCl2HCl, I will get cyanobenzene, and cyanobenzene on reaction with H2O acidic medium, I will get benzaldehyde. The name of this whole process is Stefan's reduction. Remember that? It's Stefan's reduction. Stefan's reduction. Now, my dear students, benzene diazonium chloride, if I do the reaction of benzene diazonium chloride with hot water, hot H2O, I will get phenol. And remember that if I want to get back this benzene, I can move from there to here. See how, kids, see how. If I react this benzene diazonium chloride with any of the four things, this benzene diazonium chloride with any of like H3 PO2 phosphonic acid or glucose or ethyl alcohol or SnCl2, any of these things, they will undergo oxidation, so they all are mild reducing agents. I will get benzene back from that benzene diazonium chloride. Is it clear, kids? Is it clear? Let me see in the chats. Is it clear to all of you? Very good. Zinc dust, yeah. Then from phenol to benzene also. Oh my god, thank you, sorry. Benzene diazonium chloride, if I react this with zinc dust means zinc finally divided, I will get benzene, here also benzene. So this is the memory chart. Clear, kids? Should I give questions based on this? Are you ready for the questions based on this? So I am going to give you questions. Just see to it. First question, conversions. So questions can based on conversions, and let's see how many of you can answer these questions, right? First, nitrobenzene 10 HCl A NO plus nitrozonium ion B benzene diazonium chloride. Here how I formed cyanide. See, kids, this there one step is missed. See my memory. Here one step is missed. Benzene diazonium chloride to cyanobenzene, first I should have reacted with CuCN KCN. This is missing, kids. Then I will get cyanobenzene, and then from here to here, this reagent should not be over here, kids, sorry. Here the reagent should be CuCN KCN. This reagent should be written over here. So let me write down over here. Then I will get, so CuCN KCN. I will get cyanobenzene. Then I should have reacted with SnCl2 HCl, and then this is second. Forgive me, kids. This reagent. See, I have gone over there, then I have come back. See the memory, kids. See the memory. There I realized that I have written something wrong over there. See how I realized. How I have realized, because here I was giving you question So whatever I was about to write, that has taken me back over there. See, SnCl2 HCl hydrolysis H3O plus D. So what's your D? Answer is supposed to come. Everyone just to let me know what's your answer. What should be D? Let me know in the chats if you really got it. Let me wait for the chats. Benzaldehyde, Harni ready, absolutely correct. Nagajyoti, Navadupa, very good. The bold, Maha. Sans, Bhavna, wow, everyone. Very good. Now, so everyone, the answer is benzaldehyde. Benzaldehyde is the answer. So you can kill all the questions with this. So absolutely correct, this is the answer. Now, let me tell you kids, rest of the other things. Now let me tell you SN2 and SN1, okay? SN2 and SN1. Are you ready? So let me put one box over here. Let me divide. Let me write down here SN2 and here SN1. Just see. SN2. See from this word. Only take this word and you can get all the answers. 2. 2 means second order kinetics. Second order kinetics mean a rate is equal to rate constant, Rx concentration as well as nucleophile concentration. The power is 1, the power is 1. That means both the reactant and nucleophile are involved in the rate determining step. So it's elementary reaction, and if it is being elementary reaction, that means single step reaction, elementary reaction, and elementary reaction means no rearrangement. One thing is clear. And elementary reactions means fast reaction, and to carry out this fast reaction, the nucleophile must be strong. Nucleophile must be strong enough to carry out this reaction. Now, no rearrangement, no ring expansion, no hydride shift, nothing will take place, and that means this is the carbon and this is one valency coming towards the observer side and one valency going away from the observer side, and this is one valency and this is halogen. So this is bonding molecular orbital, and just this is the polarity. That's why I'm talking about this bond, and back of this bond there is ABMO, anti-bonding molecular orbital, which is empty. So the coming nucleophile, the attacking nucleophile will definitely cannot attack over here, and it will come and attack from the back side. 100% backside attack. 100% backside attack. Now my dear students, once this is the leaving group. Now if I say this is the carbon and this is attached as the leaving group, and if the coming nucleophile is coming from the back side, and if it is not strong, it cannot hit and cannot move it out. It should be very strong and it will hit it. It will come like this. Let me take another pen, otherwise it will go away. The strong nucleophile will come from the back side and it will allow to eliminate out. It's gone. So it should be strong enough. If it is not stronger than the leaving group, cannot hit and cannot allow to eliminate out. Are you getting my point? So the backside attack, and this is known as, now here one intermediate, that is transition state, not to say intermediate, sorry for my words, transition state will get formed. The leaving group is going away from the life and the nucleophile is coming from the back. Rest of the three valencies will be like this. So transition state is five membered, very unstable. Transition state is five membered. After that, this leaving group will go away from carbon's life and nucleophile will come into life of this carbon like this. And see, it's like umbrella inversion. The leaving group has gone from east side, but it is back side, and if this carbon is chiral, we will say it's Walden inversion, so inverted product. Now see, why I said in that story it should be least sterically hindered. If these are too much sterically hindered, then this cannot attack from back side. This will not be able to attack from the back side. This much clear. I want to see green heart, then I will let you know about SN1. This is the stereochemistry. I think it's clearly visible. If not, then don't show green hearts. If it is clear, then I want to see green hearts, kids. Everyone. Very good, kids, very good. It's clearly visible. Thank you for your, kids, hit the like button. You're not. Yes, very good. Now let me tell you SN1. Just give me a second, kids. Okay, kids, very good, fantastic. Now let me tell you SN1. See, one is indicating that is unimolecular. Nucleophilic substitution reaction. That means rate of reaction is equal to reactant's concentration Rx, but nucleophile is missing. Nucleophile's power is 0. That means nucleophile is not involved in the rate determining step. This is indicating what? This is indicating that that nucleophile is not involved in rate determining step. So that means rate of reaction, who will decide? Only one of the entity, its power is 1. That means the first step is formation of carbocation, and you know that carbocation is never stable. Carbocations are having only how many electrons? See, here carbon is having 8 electrons. Here it is having only 6 electrons. So this is highly unstable. Unstable means the reaction will come more in the backward direction and less in the forward direction. So this is slowest step, and slowest step is RDS, rate determining step. Remember that this step is the rate determining step, slowest step, and once the carbocation is formed, so rate of reaction is directly proportional to stability of whom? Stability of carbocation, stability of Carbocation rate of reaction is directly proportional to stability of carbocation. So whenever you are going to deal with SN1 reaction, always see the stability of carbocation. And let me tell you, whenever carbocation is formed, carbocation formation says, think about rearrangement. Carbocation formation says, think about rearrangement. Think about rearrangement. I hope that it's clear and clearly visible to each and everyone. Then I will give questions. Do let me know it's clear, kids. It's okay. It's clearly visible. Now let me give you questions. Okay, based on SN1. Very good. Fantastic. Just see. Question number 1. Arrange the following in decreasing order of rate of SN1. First one is A1 is B is C is D is yes. Tell me the order. Which order do you think is the correct order? I want to see the order in the chats. If you really got it, and if your GOC is correct, GOC is clear. Yes, I want to see in the chat section what should be the correct order. Everyone just to let me know. Here is your order. BADC. Let me check it out. Now see, this is arylic. This should be at the last. Why, kids? Its lone pair is involved in resonance. So this is sp2 hybridized. So leave it. It is sp3. This is being benzyl sp3 and this is being benzyl sp3. So this will be at the last. Now this is due to plus M effect, due to its plus M, or you can say plus R effect, electron donating group. So it is donating at orthopara, so its plus charge will decrease. Charge will decrease. Here this is minus M or minus R, electron withdrawing group. That was electron donating group. So it will put plus charge and plus charge. So charge will increase, but carbocation is stabilized by resonance. Here also stabilized by resonance, but this is less stable. His charge will increase. So this is at the last, and this is 2 degree alkyl halide stabilized by hyperconjugation. So most stable is A. So A will lie at the first position. After A, it should be B and then D, and then at the last it will be C. If you are agreed and if your answer is correct, I would like to see green hearts in the chat. That will give me clear indication that yes, you got it. You are able to understand. That is only the indication, kids. Let me see what's your opinion about it. Fast. Speedily, just to let me know what's your opinion. Wow. Now, kids, one more thing I would like to tell you. Okay, no problem, no problem. But everyone is getting, that's fantastic. Now, let me tell you something about rearrangement, and then I will give you question on rearrangement. Okay, types. Let me teach types of rearrangement, then I will give you question. Types of rearrangement. Just see types of rearrangements. First, remember that 6-membered ring is more stable than 5-membered and then 7-membered. This is the stability of ring, right? So, 4-membered ring will try to become 5-membered, and 5-membered will try to become 6-membered. But remember that 3-membered given like this will never try to become 4-membered like this. Why, kids? Will never try to become 4-membered like this, because this is stabilized by dancing resonance. It is stabilized by dancing resonance. So it will not convert into that. So one more thing I would like to tell you, whenever the charge is on the ring itself, suppose if the ring is this, charge is on the ring, no rearrangement, never rearrangement. When charge is on ring itself, no rearrangement case, no rearrangement. So when the rearrangement will take place, I will tell you. If these points are clear, first of all, just see. Any doubt in this? No doubt. Then I will tell you how the rearrangement will take place. So let's see. If I show you that this is 5-membered ring, then how the rearrangement will take place? This bond will break from here. This will get negative charge, this will get positive charge in this way. Just see. Its bond has broken from here. Now see, it is making over here, and once it's got matured, you can see it's how many membered ring. Just see. Let me first make it like this. This is the newborn baby, like newborn bond. You can write it like this, or it could be written like this also, you can see. So 5-membered ring got converted to 6-membered. I hope that this is clear, ring expansion. If not clear, I will tell you once again. Let me know in the chats if this is clear. Show me green hearts. Kids, always, whenever it's clear, that will give me an idea about that, whether I have to repeat it or not. You kids are like my own kids, right? I'm taking too much care. I'm thinking about you only, kids. Not clear. Okay, not clear. Some people are saying not clear. Spurti is saying not clear. Don't worry, Spurti. Don't worry, don't worry, don't worry. See, kids. Okay, let me tell you once again. Let me tell you once again. See. Somebody came hearing, why are you crying? What happened to you? What's the problem with you? Oh, I'm 5-carbon ring only. That's my problem. Oh, your problem is 5 members. So what's your wish? What do you want to become? I want to have 6 carbon ring. Okay, so see, if I would have been a carpenter, I would have done tick. This bond, I must have shifted this bond a little bit toward that side. Definitely I would have shifted this bond a little bit towards that side, or not, kids, like this, in this way. Hey, go over there, and form a bond with that. Ding. I must have done this or not? Tell me, kids. First of all, do let me know. I must have stretched it like this, and I must have said, hey, you just go and form a bond with that carbon. Just go a little bit and form a bond with this carbon. See, ting. Are you getting my point, kids? Do let me know. So, but I'm a chemistry teacher. What I can do, I am saying like that. This bond should be broken up. It is gaining, this carbon is gaining electron. It is being gaining electrons, so it will develop partial negative charge, and it is a loser, so positive charge. Ting. Now see, kids, a gainer and loser story. So it has gained electrons, so it has negative charge, and that's a loser, is having plus charge. And now this one, now see, it's a heroine, it's the actress. This is being the actress. Hey, I'm Champa, and there are 2 heroes. There is Pandu. Hey, my Champa has gone. Pandu started crying. My Champa, where you have gone? And this is like what to say, Pandu. This is Ramu. Ramu is so happy. Oh, Champa is coming in my life. Love triangle. From here it's broken hearts, and there the bond is getting formed. Hey, I'm yours. Na ni. Earlier it was his. Now Champa is forming a bond with Pandu. Pandu is happy now. Hey, you have to, no, this was Pandu, this is Ramu. Ramu is saying, yay, you are mine now. Started crying. He's crying now. Now see, new, this is a love triangle, electron triangle, like love triangle. It's the electron triangle. Now see, it's a 6-membered ring wall. Now you can write it like this, or you can write it like this. Now you got it. Do let me know. Better than earlier. If yes, I want to see green hearts in the chats. Do let me know. I'm having number of things in my brain or not. Just to let me know number of things I can tell you. Oh, really, Afifa Sheikh? Really? Kids, do let me know how many of you are enjoying. Really, once you say that I'm unable to understand, your Baba is over here to tell you each and everything. I will let you know. I will tell you each and everything. Right? Question practice are going on. Question practice is going on. So this is the ring expansion. So let's see, if I give you a question like this. If I give you a question like this, that what should be the correct answer? I'm framing out the options. Major product, major. Yes, what should be your answer? Just to let me know what's your answer. Let me check it out in the chat section. What answer you're going to give? B. Gets hit the like button, smash the like. Yeah, definitely correct. Absolutely correct. Now everything is clear. Now kids, let me tell you ARSN2 reaction. Okay, ARSN2. See, ARSN2 reaction. What is the full form of ARSN2? 2 for bimolecular aromatic NSR, nucleophilic substitution reaction. Remember that ARSN2 is neither SN1, it's neither SN1 nor SN2. Should I explain why neither SN1 nor SN2? Neither SN1 because this carbocation is not stable. Why it is not stable? Any charge on double bonded carbon is not stable. Double bonded carbon is not stable. Why not SN2? See the electron density over here. This is the electron density. So the incoming nucleophile cannot attack because of nucleophile is electron rich. Their electrons are there. So electronic repulsion, due to electronic repulsion, it cannot come and attack over here. So ARSN2 reaction is taking place only this type of reaction. This type of reaction happens only with halobenzenes under acidic condition. Under acidic conditions. Very important kids. Number of questions will come from here and kids are losing marks because of this reaction. This is the anaconda type of reaction because maximum kids will lose marks. So are you ready with Josh, with full on Josh? First I will teach, then I will give all the type of questions based on this, right? Okay kids, everyone hit the like button, smash the like button, make it 400, make the likes 400 kids. Kids, make it 400, everyone make it 400. Now see kids, let me teach this reaction. This is halogen and its lone pair is doing resonance with benzene. So its actual structure is like this. Single bond has double bond character, and due to that bond length decreased by 8 picometers. So stronger bond, it's a stronger bond. So for this reaction, NaOH at 623 Kelvin, 300 atmosphere, and then H plus is used. This is known as Dow's process. Then you will get phenol. Now kids, majority of the thing is that how this reaction proceeds and what type of intermediate you will get during this reaction. So remember that reaction takes place in two steps. First, addition. Second is elimination. And this reaction proceeds with the carbanion formation. So rate of reaction. Now you kids definitely will ask how the carbanion is formed. I will teach you. Rate of reaction. Rate of reaction is directly proportional to the stability of carbanion, because here carbanion is the intermediate. Sometimes benzene also, but that is not in syllabus, so I will not consider that this is in syllabus. So remember that. I will tell you each and everything. Okay, then I will give questions, right? Now let's see how the reaction will proceed. Let's see, kids, everyone. Let's move with that. So this reaction, whenever you supply temperature, this bond will break, this bond, and this will move towards clockwise direction. This electron will move towards clockwise direction. Why? Once the plus charge is coming over here, it will get back bonding support of this halogen, back bonding support. Back bonding support. And the coming at the same time, the nucleophile will attack sidewise, neither from front nor from back. Sidewise attack will take place. Sidewise attack. Now see what this was. Aromatic, stable compound, aromatic. Now the intermediate, just see. Negative charge at this place. This is X and this is Nu and this is sp3 hybridized non-planar ring. Why I'm telling you all these things? Because if you count the electron 1, 2, 3, 4, you will start saying that it's anti-aromatic. No, it's not anti-aromatic because the ring is not planar. Okay. Now carbanion, and anything which stabilizes this carbanion will make this intermediate stable. So this is your carbanion, kids. Now see, this is the slowest step because this is unstable. This is not aromatic. So who is more stable? That is being more stable. More stable means the reaction will be more towards backward direction. So slowest step, and slowest step is RDS, rank determining step. So rank determining step, the carbanion is formed. Now the OH negative has attacked. OH is this, OH nucleophile is OH. So Na plus will come and take away this X along with electrons. So positive negative bond formation. Once again it will regain its aromaticity and once again it will become aromatic. So this is first step. Now how many things can stabilize that carbanion? That I will tell you in the next page. Till now you understood. Do let me know. At the last H plus is also added so that the acid phenol formed should not react with excess of NaOH. Let me know in the chat section how many of you are getting it. Let me know. Till now everyone got it. Clear? Very good. Now see, kids. Now who will stabilize this carbanion? Just see. Who will stabilize this carbanion? This was your carbanion. The carbanion will do resonance. So while doing resonance, the negative charge will come at ortho, at para and at ortho. So this halogen will apply minus I, this halogen will apply minus I and whose minus I is maximum. So inductive effect minus inductive effect. Who is having maximum minus inductive effect? Do let me know. Fluorine, then chlorine, then bromine, then iodine. So remember that this is the first reaction where halogen is fluorine, and remember that who is most reactive, fluorobenzene, will easily show this reaction. The one who was never showing reaction, this is the drama, this is the anaconda, this is the thing which people are thinking like, oh my god, how the fluorobenzene, and they are thinking this order is wrong, but this order is 100% absolutely correct. This will be the reactivity for ARSN2. Remember that ARSN2 is going on aromatic nucleophilic substitution reaction. Now this is the inductive effect. Now the resonance, let's see the resonance part. Resonance says any electron withdrawing group. Electron withdrawing group will do more resonance with this negative charge. It will say, hey, come over here and do resonance. It will allow resonance. So hey, come over here and do resonance. It will allow extra stability. Hey, come over here and do resonance. So any electron withdrawing group, that is minus M or minus R, like NO2, will stabilize carbanion and will increase the rate of reaction and will increase the rate of reaction. I hope that it's clear to each and everyone. There are two factors, that is dominating factors. So let me write down the sequence how the reaction will proceed. First, this is clear. If it is clear, now I am writing the sequence of the rate. So if I write down fluorine over here, then NO2, and NO2. You have to find out the sequence. A. Now B, I am writing over here chlorine, NO2, then chlorine, 2 NO2s, D, chlorine, only 1 NO2. So tell me, what should be your answer? What should be your answer for ARSN2? For ARSN2, reaction with NaOH and H+. I want to see your answer in the chat. Yes, kids, do let me know. Fast. Taking too much time, kids, do let me know. A, B, C, D. Don number 1, you are there. That's really awesome. Don number 1. Fantastic. Yes, everyone, it's A, B, C, D. Just a second, kids. Just a second. My mobile got discharged, so let me put it on charging, kids. Mobile got discharged, so kids, you must be thinking, sir, what will happen? Kids, this is the best channel. You are getting the best, right? So don't worry, huh? Definitely God will give you selection. rate of reaction. Now ArSN2 is clear. Now let me show you the data given in NCERT. That will really help you a lot. It's really, I mean it, I'm teaching in that way. We teachers are telling you each and everything in that way only, so that you should get selected. We are not just wasting time. We are not doing work for views. Really, let me tell you kids, I'm over here and we are over here just to complete each and everything and give you in the best way, so that you can get the best rank kids. So see, what's given in NCERT? NCERT corner. If I talk about NCERT corner, they have given that this reaction will require 623 Kelvin temperature and 300 atmosphere to give phenol. Now the same reaction, if one NO2 group is attached, remember that one NO2 group is attached, then do you think it will require that much of temperature? No. NaOH only 448 Kelvin temperature is required. Less temperature is required and will give you product. Now kids, if you are really able to understand, then do let me know. If I put 2 NO2s, then do you think less temperature or more temperature? If 2 NO2s are there, then this reaction can take place only at 369 Kelvin temperature with NaOH. No pressure is required. H plus 2,4-dinitrophenol. Now once it is given on page number 303, very old NCERT, and 311, new NCERT. I will get this. And now if I do this reaction, see 3 NO2s, definitely they will increase stability of carbanion up to maximum extent. So NCERT says no NaOH is required, only warm water. Warm water is sufficient to carry out this reaction, and you will get picric acid 2,4,6 trinitrophenol. If you want to check, you can check out your NCERT, you will get it. Whatever the page number I have told you, 303, very old NCERT, 311, new NCERT. It's given over there, right? Got it? See the effect of NO2s. This is clear, perfectly clear. Do let me know in the chat section. Is it clear to all of you kids? It's given or not? Do let me know it's given or not. Now, electron density will decrease, not increase. Somebody is asking electron density will increase. No, it will decrease due to resonance. Density means dispersal of charge is there. So stability will increase, right? And dispersal of charge will be there. Now, for this chapter, let me tell you next reactions, other reactions, right? Now, let me give you one chart for rest of other reactions, right kids? Let me give you one chart, memory chart for the reactions, rest of the reactions. See, if I write down C2H5Cl, this is my main hero, right? And if I do the reaction of C2H5Cl with KCN, you know that K positive ionic bond Cn, carbon is having negative charge. So this is the attacking agent. This will come into the life of carbon and attack over there. So what product I will get? What product I will get, kids? Definitely I will get CH3 CH2CN cyano. It is ambidentate nucleophile. Ambidentate nucleophile. Am I clear, kids? And this is ionic bond. But if you carry out the same reaction with AgCN, listen to what I am saying. If you carry out same reaction with AgCN, so see to it, Ag, pseudo inert configuration. If you see pseudo inert configuration, pseudo inert configuration. So Fajans rule says it is covalent bond. Which bond? Covalent bond. So will not ionize. So nitrogen is donor. Here carbon was donor. Here carbon was donor. Here nitrogen is donor. So nitrogen donor. So the product will be CH3, CH2, and C, isocyanide. You will get isocyanide. There you have got cyanide. There you have got isocyanide. Cyanide and isocyanide. These two reactions clearly visible. Just do let me know, is it clear or not? Is it visible or not, kids? Visibility is there? Kids, do let me know. Is it visible? Then I will give you a number of questions. Do let me know, kids. Clearly visible or not? Okay, I will give at 9:30. One break I will get at 9:30, kids. Break I will get at 9:30, right? Don't worry. 9:30 I will give you one break. Now see, let me complete this chart. Now see, kids. If the same type of reaction I could have carried out with C, AgCN, see over here AgCN, once again this is covalent bond, and CN we have done already, we have done. So if I have done with KNO2 AgNO2, KNO2 AgNO2, KNO2, the ionic bond KON double bond O. So this is negative charge, this is better donor, so I would have got CH3, CH2, ON double bond O, ethyl nitrite, ethyl nitrite. But AgONO, what is the bond, kids? Covalent bond. Now what I have got, what I would have got, I would have got CH3, CH2, NO2, nitroethane. Once again, ambidentate nucleophile, that is ambidentate. These are also two are ambidentate nucleophile. Now see, kids, if I would have carried out its reaction with C2H5ONA, C2H5ONA, then this will be known as, in presence of dry ether, this is known as Williamson synthesis. Williamson synthesis. Williamson synthesis. I would have got C2H5. Oh, C2H5 diethyl ether. Now, if its reaction I would have carried out, kids, if I would have carried out its two types of reaction, I would like to focus on. First reaction is with NaI dry acetone. What do you call it, kids? What do you call it? Finkelstein reaction. I would have got C2H5. Finkelstein reaction. Finkelstein. Now, if I would have carried out this reaction, fluorides of antimony or cobalt or Ag or mercury, I would have got C2H5F. Now, if I would have reacted this C2H5Cl with LiAlH4, I would have got ethane C2H6. All the reactions, I think really it's a good memory chart. Kids, do let me know. Show me green hearts if I have really done hard work. Schwarz reaction. Yes, this will be known as Schwarz reaction. And if the visibility is really good, do let me know. If the visibility is really good, do let me know, kids, so that I can give number of questions. This is known as Schwarz reaction. I hope that it's clear now. Very good. So let me give you one question. My question to the public is that if I am being provided with CH3, CH2, Cl, NaI, dry acetone, I will get A with KOH aqueous, I will get B on reaction with thionyl chloride known as Dargen's reaction. I taught you in hydrocarbons, I will get C, and C on reaction with KOH alcoholic heat. This I taught you in class 11th chemistry. D, and D on reaction with O3 zinc and water, class 11th chemistry. What should be the product or products? I would like to see the answer in the chat, kids. Once if you have done it, do let me know. Yes, kids. Formaldehyde. Let's see. Let me check it out whether your answer is right or wrong. This is Finkelstein reaction. KOH aqueous, ethyl alcohol, thionyl chloride, ethyl chloride, Dargen's reaction, best method, KOH alcoholic heat, ethene, fantastic, kids, fantastic. And now 2 moles of formaldehyde. That's really fantastic. Now, one question I will give based on ARSN2, and maximum students will get wrong answer. Are you ready? Are you ready? Question based on ARSN2. I will give you question based on ARSN2, and I am telling you most of the students will get wrong answer. Question based on ARSN2. Maximum people will get failed. Let me write down. Maximum students will get failed. Are you going to accept this challenge? Do let me know, kids. Challenge is accepted or not? I'm going to give you options. Yes, waiting for your answer, kids. Let me see your answer in the chats. Do let me know. Yes. Fast, fast, kids. Fast, fast. Your rank is in your hands. B. Maximum people are going for B. 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 My God. You are really awesome. I think now intelligent students are left. I think intelligent students are left now. Very awesome, kids. Your response. I'm highly obliged, feeling accomplished with your stupendous performance. See, this halogen with respect to this halogen, this is at para. With respect to this is at para, and with respect to this at meta. At meta with respect to this, and with respect to this it's at para. So this is a leaving group, that is not a leaving group. So this is the correct answer. Congratulations, congratulations, kids, those who have got the correct answer. So done and dusted this chapter. This chapter is done and dusted. Now after this I'm going to start with alcohol, phenol and ether, then aldehyde ketones, and then carboxylic acid and its derivatives. So let's start with alcohol, phenol and ether, question and answers and the basics which are involved over there, right? So ready, kids? Are you ready with full on Josh? Alcohol, phenol, ether, questions along with basics. Questions with visualization of concepts. I hope that everyone is ready. I will clear this, I will clear this, I will clear this. Each and everything I will clear along with basics. So show me the Josh in the form of fire. I want to see the Josh in the form of fire. I want to see. Break. Okay. So let's okay. So it's a break time. 21, 24. So let's meet at 10. So let's meet at 10. Okay. Okay. Let's meet at 10. It's a break time. Break till what's the time? Just let me see in the chats. Okay, Supreme. Okay. No, it's not 10:30. It's 10:15. Okay. Break till 10:15. 10:15. 10:15 is fine. 10:15. And really, I will move in the sequence. I will give questions sequence wise and I will teach in the sequence. Okay. And this after the break. after break. Okay, this I will teach after break. Okay, come with full ATPs. Make a promise that you will come with full ATPs, then only I am going to give break, otherwise I will not give break. Okay, make a promise that you will come with full on ATPs, with full on Josh. Just make a promise, otherwise I will not give. Make a promise. Let me see in the chats. Very good, Umi Kulshum. Okay, Vishal. Okay. Okay, okay, okay. I got it. Got it. Yeah. Kids, are you back? Just to let me know. I'm on time or in time. I'm on time or in time. Let me check it out. Yeah, perfect time. Perfect. Welcome, Unacademy. Just to let me know in the chat section if everyone is back with full on energy. Kids, let me tell you, I have not done the dinner because once if I have had it, then I will feel sleepy. So that's why I haven't done my dinner after the class whenever I'm getting free. That I don't know, that should be the dinner or breakfast, that I don't know. But anyways, let me see in the chats. Everyone show me some fire in the chat section if you're ready, because I will go in the sequence order. I will give you the question first. I will give you the concept, then question, concept, then question. That is the strategy which I'm going to follow. I want to see fire in the chat section. Yeah, Sahana, that's fantastic. Soumya, Jayashree, concept questions, concept questions. I'm going to go with that thing. Concept questions, concept questions, concept questions. Let me check it out. Let me check it out. What's the response over here? Concept questions, concept questions. Everyone, just to let me know. Everyone, just to let me know. Everyone, just to let me know. Concept questions, concept questions. Fast, kids, fast. Everyone, fast. Okay, concept questions, concept questions. Let's move here. Questions, concepts. Okay. Now, let's it go. Alcohol. Alcohol's preparation, right? First, from Grignard reagent. We should know what is Grignard reagent. If we know what is Grignard reagent, just see to it. Carbon attached with magnesium and halogen. Just focus over here. Carbon del negative. It's a strong base as well as strong nucleophile. So it will be like this. Carbon having negative charge. Remember that. Carbon will move with electron. Now let's see from Grignard reagent how the preparation will take place. Just remember, this is Grignard reagent, organometallic compound. Now see, kids. If I write down any carbonyl compound like this, C double bond O, it will depend on these R's, whether it is aldehyde or ketone. And in front of this, if I write down Grignard reagent R MgX, just try to understand how the reaction will proceed. Just try to think. Don't mug up, don't cram it. Do not cram it. Just see, this carbon is having del positive charge, oxygen del negative charge, and this R is having what charge? Keep on writing, whether I see or I don't see. It's your work to write down. This carbon will have del negative. Now this del negative will go with this, right? Will form an intermediate. This positive part will go over there. What is going to get formed? Just see. This was the original part. Mgx has come over here, and carbon, this carbon, Grignard reagents, carbon bond formation, right? Now this is unstable. Why it's being unstable? Anyone? Can you please do let me know why it's unstable? This is non-metal and that is being metal. Non-metal and metal. Non-metal and metal. This bond is not of equality, so it will further react with water. Water like H del positive, OH del negative. So it's like this, right? So final product you will get R carbon. This is the original part. What's being added? 1 R of Grignard reagent and H. R and H you have to add. You will get the product. Now see, to this carbon, carbonyl carbon, R has been added and to oxygen, hydrogen is being added. Now this is alcohol. Now, clear? Now, I will ask questions, right? Once this is clear, just to let me know it is clear. I want to see green hearts. If it is clear to each and everyone, then I will give questions. Now see the questions, the quality questions. See how you can proceed. But first, see, here is the question. H double bond O. Now see, if I react methyl magnesium bromide, zinc and water, zinc will split out water easily. If I react with this ethyl magnesium bromide, zinc and water, if I react it with phenyl magnesium bromide, zinc and water. Now see kids, what's a common thing? How to form the product? The original one, write down original one. I have written the original one. Now what I'm supposed to do? To the original part, what I'm being supposed to do? Kids, just to let me know. Just see what is the R part. Just focus on the R part. I'm supposed to add this R part. R part del negative R. R part this del negative R. R part this del negative R. Now what I'm supposed to do? To the oxygen just add hydrogen. What's the special thing? This was formaldehyde. What do you have got? Anything special that you have got, kids? Do let me know. In all the three things, one thing is being very special, that all they are 1 degree alcohol. Always you will get primary alcohol. If you're liking it, just to let me know. I want to see thumbs up in the chat that you are really enjoying it. Whenever there is formaldehyde, always you will get primary alcohol. I'm not tired. Remember that Baba HSP is always there with full on Josh. Do let me know in the chat section if you're really getting it. Always primary alcohol. I want to see your energy also, kids. I want to see the same energy. See, that day I have taken marathon for 12 hours. Today I will tell you each and everything. There's no hurry. I will tell you each and everything. Then the questions. Really, your energy level is giving me energy. That's awesome. That's the thing. Your selection, I will tell you how to get the selection. Now, other than this aldehyde, you can take any other aldehyde. If you have taken any other aldehyde, just see acetaldehyde. If I'm being provided with acetaldehyde, now it will never give primary alcohol. It will always give secondary alcohol. See, methyl magnesium bromide, zinc and water. Make chemistry super easy. Any Grignard reagent, if you react, whatever the Grignard reagent you are going to react, you will get always 2 degree alcohol. Just see to it. Once again, what I'm supposed to do? Write down the original one. I have written original one. Now what I'm supposed to do? To the original one. Here this one, just add this one and this one. Now you can do this thing in your memories only and you will feel super duper easy. That 2 degree alcohol you are getting secondary alcohol. Right? Now it's very clear, all aldehydes other than formaldehyde, all aldehydes give secondary alcohol other than what? Except HCHO, right? Because HCO has given primary alcohol. Now if I tell you that ketones, if you take any ketone, my dear students, any ketone, it's a turn of ketone. Just see, if I take any ketone, what do you think? What you will get? What will you get, kids? Original one, original one. This is original one. What are you supposed to add? Here the Grignard reagent part here. So all ketones will always give tertiary alcohol. Agreed? They will always give tertiary alcohol. Done and dusted. Done and dusted. Now I will give one question, right? I will give one good question. If I say marvelous question, and let me tell you, maximum students are going to get failed. Maximum students will get failed. A plus B. A is carbonyl compound. B is Grignard reagent. Zinc and water. You are getting C6H5 CHOH CH3, right? Now question is, A is options are C6H5CHO, B is CH3CHO, C is A or B, D is none of the above. Just see this question. Once you are ready, just to let me know. I will start the poll. C. Most of the students are going for C. Let me check it out. What's your answer? C. Very good, kids. Everyone passed. That's really fantastic. If you take this one, if you react with, then the Grignard reagent will change. Then the Grignard reagent will come methyl magnesium bromide, zinc and water. If you take this one, then the Grignard reagent will come out to be C6H5MgBr. That's really fantastic. Really fantastic. Now, next preparation, kids. Now, next preparations, number of preparations I have told you. See, already we have done, where we have done, completed in class 11th marathon. What? From acidic hydration. This one we have completed or not? Just to let me know. Acidic hydration we have completed. Then OM-DM reaction, oxymercuration, demercuration we have completed. Then HBO reaction we have completed. Then from esters we have completed. These we have already done. These reactions, these preparations we have done. Now, my dear students, the most important thing in alcohols is that we have completed an RX and aqueous KOH aqueous. This we have done. Now, my dear students, so let's deal with the chemical properties of alcohol, right, kids? These we have done or not? We have already completed. Now, chemical properties, chemical reactions of alcohol. Chemical reactions. In the chemical reactions, first thing is distinguishing test. These holds a hell lot of weightage. Distinguishing tests. How many distinguishing tests do you know, kids? Distinguishing tests are 3. These are 3 in number. First one is Lucas test. If I talk about Lucas test, we should know what is a Lucas reagent. If anyone is going to ask what is being Lucas reagent, so remember the clear thing, an equimolar mixture of, remember that an equimolar mixture of concentrated HCl plus anhydrous ZnCl2. Remember that this is Lucas reagent. How the Lucas reagent is going to affect the reaction? ROH ZnCl2 is being Lewis acid. Lewis acid will attack on the lone pair of oxygen. So you will get ROH, this positive, ZnCl2 negative, and now oxygen will say I can't tolerate this positive charge, so eliminate out, and you will get carbocation. Remember that once the carbocation is formed, always think about rearrangement, and after the rearrangement attack chloride on the most stable carbocation. The major one will be the most stable, so the rate of reaction. So is this clear? So can you tell me that the rate of reaction of Lucas reagent? Lucas reagent will speedily react with which alcohol? Which alcohol? This is tertiary alcohol. A is tertiary, B is isopropyl alcohol, secondary alcohol, and let me give you the C is primary alcohol. Which alcohol will be attacked by easily by Lucas reagent? So the answer is Lucas reagent will attack in this within fraction of seconds, within fraction of seconds to give CH3 as I have told you. CH3, how to find out? Because it is a distinguishing test. How to find out that reaction has taken place? The solution is turbid. Turbid means translucent. Translucent, that means turbidity will appear within fraction of seconds. Turbidity will appear. Now it will, and simply if you shake with, simply shaking, even shaking with HCl, this is very, very important. Simply shaking with concentrated HCl also going to react. Now this with the Lucas reagent will give turbidity after 5 minutes. Turbidity after 5 minutes, and this will not react at room temperature easily. If you add Lucas reagent, then at room temperature you will get turbidity after very long period of time. Turbidity after a long period of time. Right kids, it's clear. Let me check it out that whether you are able to understand or not. Now see kids, do let me know in the chat section. Everyone got it? I want to see in the chats that it's clear or not. Kids, I'm with full of slow appearance of turbidity. Yeah, thank you, the bold. I'm moving with each and everything. See, this is the true thing, that I'm covering each and every single point of NCERT. See kids, I got the comment. Thank you, Don number 1. Thank you, Murugan Ritesh. Wow, Ritesh is there. Wow. Thank you, Chaitanya Mashkare. Kids, really you are giving me lot of energy. That's really awesome. Now see kids. Now, this was the question and the reaction will move like this. Now, if I give you one question, question is over here. Just see to it. that question is given like this: neopentyl alcohol on reaction with the Lucas reagent, what product you will get? So let me give you the options. Option A, CH3, CH2Cl. This major product we are asking about, major. B is CH3Cl, CH3. C is CH3Cl, CH2CH3, and D is none of the above. None of the above. So just see to this question, my dear students, and then I would like to see in the chats what's the correct answer. Do it in your brain, and if you have really done it, let me check it out in the answer in the chats. What's your answer? Neobutyl chloride 1-chloro. Okay, some are going with A, some are going with C. That's kids. What are you doing? Some are going with A, some are going with C. What's going on? No, not at all. See kids, not at all. Your answers are coming wrong over here. Just see what is neopentyl alcohol. Neopentyl alcohol is this compound, CH3, CH2OH. Now once Lucas reagent will attack over here, it will form O positive, ZnCl2 negative. Now this will eliminate out, you will get plus charge. Once the plus charge you are getting, think about rearrangement. So rearrangement, 1,2 methyl shift will take place. 1,2 methyl shift. So the most stable carbocation will be CH3, C plus CH3, CH2, CH3. This is most stable carbocation, most stable, more formed, more responsible for major product formation. So what should be the correct answer? The correct answer will be C. This here you have done mistake. Where I was thinking of that you are not going to do mistake. Here you have done mistake. You missed it. Everyone got it. It's clear. Just show me green hearts. Once it's clear, don't take too much time. Let's make it fast. If it is clear, hey kids, do let me know it's clear or not. Yeah, the bold, you have forgotten about methyl shift. Yes. Now it's clear. So once you got it, don't forget to show me green hearts. Everyone, what are you doing? What's going on, kids? Yeah, now. Next, the chemical preparation Victor-Meyer test. This is for rank deciding. If you want to have a rank, then only go for it. Otherwise, you can leave it. Rank deciding is, if you are thinking of more than 680 marks, then only go for Victor-Meyer test. Otherwise, you can skip it. Victor-Meyer test. Now, if simple question, they are asking a simple question, then it's very simple that primary alcohols with Victor-Meyer test will give blood red color or red rose color, and secondary alcohols will give on Victor-Meyer test will give blue color. Blue eyes hypnotize, blue color. Now tertiary alcohols, no color. Now this is simple one. But if they are asking tough question, then they will ask everything in detail. If they are asking tough question, then they will ask each and everything in detail. Let's see in detail. Detail is the reagents. Remember the reagents. in detail. This is your alcohol CH3 CH2OH reaction with phosphorus plus I2. Remember that reagent CH3 CH2I, then they will react it with HNO2, nitrous acid. Remember that they will give you HNO3 also. Don't go for HNO3. It's HNO2, nitrous acid. What is the name? Nitrous acid, not the nitric acid. Now, how the nitrous acid is going to react? Let me show you the reaction. Write it properly like this, CH3. No. I have missed something. Before nitrous acid. See, even I have missed. AgNO2, silver nitrite. First, AgNO2, silver nitrite, AgNO2. Then you will get CH3, CH2, NO2. Now it is having two acidic hydrogens. So now nitrous acid. Will come N double bond O OH. This is known as nitrous acid. The reagents, the sequence, each and everything they will ask. Nitrous acid. Now just see what will eliminate out. From here you can see two hydrogens and one oxygen. Water will eliminate out, kids. Now you will get a compound CH3 CNO2 double bond NOH. It is known as nitrolic acid. Now kids, when it is doing reaction with NaOH, a complex of red rose color, you will get red rose color complex. No need to go for that complex, will not be asked, well, not in syllabus. So red rose color you will get. Now see how many compounds will give this reaction. This compound, this compound, this compound, and this compound. These many compounds are responsible for giving this test. Clear? So remember the reagents. Remember, let me see in the chats what up the kids are doing. Kids, everyone clear to all of you Victor Meyer test? Is it clear, kids? Do let me know. Wow, DJ, good. I don't know what's the duration. I know only one thing. I have to teach each and everything. Kids, hit the like button. Make it 500. Let's see. Smash the like button, kids. Very good, Boost Gaming. Wow, that's really awesome. Now let's see with secondary alcohol how the reaction will proceed with secondary alcohol. Let's see. Let me see the secondary alcohol. How they are going to react. R2CHOH once again will react with P plus I2 R2CH I, then AgNO2 silver nitrite R2C NO2H. Now this is having single hydrogen which is acidic. Now how to eliminate out water? So see, nitrous acid will come in a decent manner, in different way. Just see the way it turned, flipped, it's flipped. Left hand side, right hand side, right hand side, left hand side. Now the water, once again, the water will eliminate out. The reaction will proceed with the elimination of water. And now just see what we are going to get. We will get RCNO2 and N double bond O. It is known as pseudonitrile. It is known as pseudonitrile with NaOH will give blue eyes hypnotize. La 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 la. Blue eyes, blue, 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 blue color, gets clear. If you're really enjoying, can you see the sleepiness in my eyes, or my eyes are just looking full on energy? Just to let me know, kids. I want to see in the chats. Hey, 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 hey. Do let me know, my dear students. Prajwal ready? Wow. Yeah. Nalla iruku re. Kids, you are enjoying, really enjoying. Sahana is there. Wow, Sahana. Katrivaran is there. Bhuvana is there. Madhu, Liha is there. Wow, and the eyes are with full of enthusiasm. Eyes are with full of enthusiasm. लिखना है चैतन्य मिस्करे सर रुको जरा चैतन्य मिस्करे सही सर रुको जरा लिखना है ओके राइट इट डाउन प्लीज okay now see if I would have taken tertiary alcohol then do you think any acidic hydrogen is there? No acidic hydrogen, so kids no color. See, once in year 2016 they have asked this question. It's a thing in time year 2016 they have asked this question. CH3 NO2, will it react with nitrous acid, kids? They have asked this question, will it react with nitrous acid? So what's your answer, kids? Do let me know. Oh, smart answer. There is no acidic hydrogen. As no acidic hydrogen, so no reaction. So no reaction. Where is the time to hate? Hey, where is the time to hate when there is so little time to study? So in the chat, kids, don't waste your time. Where is the time to hate when there is so little time to study? Okay, kids, let me see your reactions. What reactions are given by kids? Hey, kids. Yeah, you can talk about there is no alpha hydrogen. Yeah, one kid is saying that yeah, so there is no alpha hydrogen. That alpha hydrogen is only the acidic hydrogen. That's I was talking about. Yeah. Thank you, Sahana. Thank you, Pani Baba Lingesh. Wow, Prajwal. Now see, you can talk about this hydrogen. There's no alpha hydrogen. No alpha hydrogen. Okay, right. So this is clear. Now, the third reaction. Third distinguishing test. Third is reaction with copper or silver or gold at 300 degrees Celsius. That is 573 Kelvin. Let's see. CH3 CH2 OH. So I have written primary alcohol. This is being primary alcohol, but in a decent way. If you react it with copper and 300 degrees Celsius, what is going to happen? See, dehydrogenation will take place. This hydrogen will eliminate out. Can you see? This hydrogen will eliminate out. Dehydrogenation. Your hydrogen has gone. You have produced aldehyde. Your H2 has been eliminated out. So we can say dehydrogenation and loss of hydrogen is dehydrogenation, or loss of hydrogen is oxidation. Now let's see secondary alcohol. What is going to happen with 2 degree alcohol? CH3 H OH. Once again, dehydrogenation. So you will get ketone, right? Yes, sir, I have got it. Oh, rhombus-sulfam. Now, kids, do you think the same thing is going to happen with tertiary alcohol? Just think about it. Just chill. Think about. So there is, do you think at this place there is any hydrogen? No, Baba, no. No. So water will eliminate out this time, not the dehydrogenation, dehydration. This is something new, dehydration. So the product will be, the name of this product is isobutylene. Isobutylene is the product. Everyone clear? Let me check it out in the chat section. It's clear. If clear, don't forget to show green hearts. If it is not clear, you can tell me in the chat section. If it is clear, rhombus-sulfam, the idiyappam muruku things are becoming rhombus-sulfam, then you can do, let me know with the green hearts. I want to see kids. That I want to see kids. Everyone, do let me know. Okay, now you got it. Now, one name reaction, fantastic name reaction, I'm going to tell you. That is fantastic reaction, Pinacol-Pinacolone rearrangement. Have you heard this name? Anyone, have you heard this name, Pinacol-Pinacolone rearrangement? Pinacol-Pinacolone rearrangement. Pinacol-Pinacolone rearrangement reaction. Now, people must ask, what is Pinacol? First of all, see, this is the Pinacol. These are, can be alkyl or can be alkyl or aryl, or even they can be hydrogens. This is Pinacol. Now, how the Pinacol will do rearrangement? That is the question, $1 million question, that what will happen if I put H2SO4 in front of this. So just see, no need to cram it. We will go step by step smoothly. Are you ready? Are you ready for this? Okay, let's see. This is the smallest Pinacol kits, ethylene glycol, COH, H, and H. Now we have added H plus from acid. Now H plus, definitely H plus, don't know anything. I don't know anything. I know only lone pair. Where is the lone pair? I will attack on it. Okay, come on and attack. Okay, so what will be formed? H, C, H, O, H, C, O, H, 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 and one extra hydrogen will come. Oxygen will start crying. Oxygen will start crying, and oxygen will say, I can't tolerate this positive charge. Hey, you are just saying like this. So I have one dialogue. I have to remove water. मेरे को पानी निकालना है. I have to remove water. Just eliminate out water. मेरे को water. I have to eliminate out water. So what you will get, kids? You will get HCH OH carbocation. Whenever I see carbocation, my mind say, my mind, just think about rearrangement. Whenever I see carbocation, always my mind speaks about Think about rearrangement. Think about rearrangement. Everyone say, whenever I see carbocation, always my mind speak. Think about rearrangement. Think about rearrangement. Now, if the rearrangement is taking place, this hydride shift will take place. 1, 2, hydride shift. This is very, very important reaction. Now, the carbocation is stabilized by what? Anyone? Any kids? Do let me know. Just see. It is 6 electrons only, and it is having 8 electrons and 2p pi back bonding. 2p pi back bonding. Stabilization. So this carbocation is more stable. More stable. Now later on, H plus we have to eliminate. Yes, go. Positive negative bond. Na. Your answer. Now one question for you people. You got it? Just do let me know in the chat section you got it or not. If you got it, then only I am going to give question. If you got it, then only question will come. Otherwise not. Otherwise not. Do let me know. Do let me know. Okay, you got it. So here the question is, the question for you people is, let's see, CH3, OH, CH3, COH, CH3, H2SO4. I will not give the options. I will directly write down the answer. Just go through it and do let me know whether you got it. Then I will give the answer. You have to check it whether your answer is right, matching with my answer or not. Okay. Okay. So see, the H plus from there will come over here on the lone pair, will form O plus H2. Water will eliminate out plus charge. Then what will happen? 1,2 methyl shift will take place. So this H plus will eliminate out negative, positive, the bond. My answer is CH3, C double bond O, CH3, CH3, CH3. I got this answer. Is this your answer? If this is your answer, I want to see. Yes, green signal. You know the green signal. Now, after this, next reaction is acidic dehydration. We have completed. Acidic dehydration where we have completed? Acidic dehydration already completed in hydrocarbons. Already been completed in hydrocarbons, right? So this was all about alcohols. Now let me come to the ether. But before coming to the ether, let me tell you phenol. Let me give you the mind map of phenol, right? Phenol. Phenol is also known as carbolic acid. Before I give you the memory map, let me tell you one thing. If I put phenol in water, remember that. If I add phenol to water, what will happen? This is weak acid. Weak acid. So water will snatch its proton . Remember that they will remain in equilibrium, right? But this phenoxide is thermodynamically more stable, kids. Just keep this thing in your brain, hippocampus. Very, very important. Phenoxide is thermodynamically more stable. Very, very important. Now question arises, why phenoxide? What is there in phenoxide that thermodynamically more stable? If you draw its resonating structure, then see negative charge will come over here. If you draw its resonating structure, then plus charge and negative charge. Now you know that this plus charge will attract negative charge. So negative charge will vanish easily, but here negative will ripple, or you can say negative charge is more stable on more electronegative atom, but plus charge is not stable on more electronegative atom. So you can talk like this also, that negative charge is more stable on more electronegative atom. Some people or some books also talks like this, that everywhere there is negative charge, so there is no charge separation. This word you can get, there is no charge separation, no charge separation, and that's why it is stable. Stable as there is no charge separation. Got it? Now let me give you the mind map. Once do let me know, because I always think about you. Oh HSP, you are the greatest magician on this world, in this world. It's just to let me know. Oh HSP, you are the greatest magician. Oh Krishna, na 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 na. No. Very good. Now let's move here. How's the Josh, kids? Do let me know how's the Josh. Thank you, Nandini. Thank you. How's the Josh? Just see my eyes. There is not even a single count of sleepiness, full of enthusiasm, and this is because of you. Your energy level, kids. Your energy level. Boost Gaming. Thank you. Question, don number 1, question. Okay. Now question. But before giving you question, let me give you mind map of phenol. Mind map of phenol. Everyone ready? Then I will give questions. This is phenol, also known as carbolic acid. What? Say what? Carbolic acid. Phenol is also known as carbolic acid. Now when you reacted with bromine water, remember that Br2 water, aqueous, then you will get this phenol will convert into phenoxide, and that is having a strong ring activating tendency. So 3 bromines will add up, remember that. And it's a very, very important thing that it is white in color, and that's why it is a distinguishing test. White PPT, white precipitate of 2,4,6 tribromophenol. Now if it would have been reacted in this is PPS, polar protic solvent, but if non-polar solvent, if any non-polar solvent along with bromine you would have taken, like carbon disulfide or chloroform, then you will get major product as parabromophenol. This is being major. And orthobromophenol will be minor one, right? This will be minor because of steric hindrance, like less steric hindrance. Less steric hindrance is over here, kids, right? Now, kids, if you do the nitration, oh my God, you will feel that what's going on, because nitration, if you carry out nitration directly, nitrating mixture, if nitrating mixture would have been used, then explosion will take place. Explosion will take place and you will get less yield or poor yield, means less amount of product formation will be there, because this reaction is vigorous reaction. So you will get poor yield. Yield means the product formation. So NCERT says that how will you carry out this reaction just to get the best yield? That's the best yield, how to get? So there is one way, reacted with sulfuric acid. Sulfonation is a very slow process because it is being reversible. So at two positions, SO3H will add up like this, SO3H. Why not here? Because of steric hindrance. Now you do nitration. Now NO2 will say, hey SO3H, just go away from here, just move here. He's saying, oh, I will go, but I will take some time. Slowly, gradually, I will go. There will be no explosion. Why there explosion? You know that nitrating mixture is concentrated HNO3. Concentrated HNO3 is oxidizing agent also. Concentrated H2SO4. This is oxidizing agent. So here you will get best yield of picric acid, and picric acid itself, it's an explosive, TNP. TNP means trinitrophenol. Now, last but not the least, I would like to say with dilute NHNO3. This is the question examiner will definitely ask. So here, which is major? That is $1 million question. It holds a whole lot of weightage. Who is major? Remember that due to intramolecular hydrogen bonding. Remember that para is not major over here. Don't see the steric hindrance. See the chelation. Due to chelation, 60% formation, ortho being major, chelation. Got it? Crystal clear? Then only I will give questions. I'm going to give questions. Do let me know, is it clear to each and every one? Do let me know, kids. Just do let me know. Everyone. Very good, everyone. Ortho is major. Yes, ortho is major. You are interesting, teacher. Thank you, Ishika Kesharwani. Thank you. Really, thanks. I will keep your words in my mind. These words definitely the best. Now, question over here. Let's see to it. This is your benzene. Reaction with Cl2 anhydrous AlCl3. You got A that has been treated with NaOH. 623 Kelvin, 300 atmospheric pressure. Along with H plus, you got B. Now B has been treated with zinc dust. Now let's see, you got C. This has been undergone ozonolysis, O3 zinc and water has given D. Now it's been treated with NaBH4. NaBH4 acidic medium, you got E, then reacted with H2SO4. Now what is F? Just find out what is F. Let me see in the chat section who is going to give the correct answer. Hey everyone. Let me see what answer. Yeah, but D is, yeah, you're right, Sahana. But what's the Shivani Gogya? Let him do whatever he want to do. Where is the time for that when there is so little time for the questions? So let him do. Yeah, no one till now, no one to give the correct answer. So I am going to move ahead. Just see the benzene. The benzene will react to give the chlorobenzene. So A is chlorobenzene. Am I right? This is Dow's process. Dow's. So this is phenol. This is zinc dust. Zinc will snatch its oxygen to form Janu. This is benzene. Ding. Now ozonolysis. So it will cut it from here. Tick. 3 moles of glyoxyl you will get. Now, oh yeah, then reduction you will get glycol. Now just think about it. Right now, just half an hour back, I have told you Pinacol-Pinacolone rearrangement. Do you remember? Pinacol-Pinacolone. So acetaldehyde is the answer. Just say now. Oh shit, this shit, that shit. I missed it. Pinacol. That's why I was telling you. I kept on saying that you will miss it. You will miss it. Now, let me tell you oxidation. First, let me tell you oxidation of alcohols. Now, the oxidizing agents are of 2 types. Let me divide them. One side, another side. One side is being MOA. Have you heard the name MOA? Ever have you heard the name MOA? MOA means mild oxidizing agent. Mild oxidizing agent. So PCC is the best MOA. What is PCC? PCC is 1:1:1 mixture of pyridine, HCl, CrO3. Now we know that this is base, pyridine is being base. This is being acid. Now acid will react with base, its proton will attack on the lone pair, so it will convert into pyridinium. Chlorine, CrO3. So what is the full form? Pyridinium chlorochromate. What is the name? Pyridinium chlorochromate. Now this is MOA, right? Or you can use simply CrO3 anhydrous. If CrO3 is without water, then also it is also MOA. Now examples of SOA. Strong oxidizing agent. Let's see. CrO3 aqueous, because CrO3 when reacts with water will become chromic acid, H2, CrO4 being chromic acid. We can use K2Cr2O7 acidic medium, that also SOA, Na2Cr2O7 acidic medium. Now Jones reagent. What is being Jones reagent? CrO3 plus H2SO4. This is also being SOA. Now KMNO4, you know that potassium permanganate acidic medium. Now concentrated HNO3. Any of these can be utilized or used, right? MOA and SOA. Let's see what MOA and SOA will do. Are you with full on Josh, full on energy, kids? Now let's see. If I give you primary alcohol, CH3, CHHOH, one C, it will eliminate out with MOA like PCC. Reaction will get stopped at aldehyde only with same number of aldehyde. But if SOA has been used, then the reaction will not stop at aldehyde. It will go up to acid. It will go up to acid. See the difference here? Aldehyde is the result. Here, acid is the result. See the difference between MOA and SOA. Is it clear, kids? I think you got tired now, eh? Let me check. Tell me, you got tired now? Now so you got tired? Just to let me know, what are you okay? Or you need break? Let me see what's the time. What's the time? Yeah, now 23. Yeah, at 12 we can get one break, right? At 12. Do let me know. At 12, at 12. No, kids, right now no break, because let me complete ether, up to ether. Cleavage of ether. Once I am going to complete cleavage of ether with the concept and questions, then I will give break, right? Then definitely I will give break, right, kids? Right now no break. Now 2 degree alcohol, let's see secondary alcohol. See, R2CHOH. Either I am using MOA or SOA. I will get ketone. I will get ketone. With same number of carbon, whatever the carbon it was having, same number of carbon. Now with MOA, whatever I do, I will not get any product, but with SOA plus heat, I will get product according to Popoff's rule. Product according to Popoff's rule. Now what is this Popoff's rule? Let's see. Popoff's rule. Okay, so let's see what is this Popoff's rule. Suppose I am provided with a compound like this. I have used KMNO4 acidic medium, so I will get ketone 1, 2, 3, 4, 5, 6. carbons 6, 1, 2, 3, 4, 5, 6, 3 and 3, 6, 3 and 3, 6. Now Popop's rule says that this carbonyl group will go with that alkyl group which is having less number of carbons. This carbonyl group will go with that alkyl group which is having less carbon, that is having 1 and this is having 4. So the breaking will be from here. Breaking will be from here because that carbon was having only 1 carbon and this was having 4. Let me write down, otherwise you will forget. This alkyl is with 4 carbons and that is only 1 carbon. So how many carbons are left? 4. So it will oxidize COOH. So one carboxylic acid I will get butanoic acid like this, and another I will get CH3COH. So these two acids we will get as the mixture. These two will be the answer. Clear? Popop's rule is clear. Kids, do let me know. Is the Popop's rule clear? Now, let me tell you about tertiary alcohols. Are inert towards oxidation. Are inert towards oxidation. Only there is one tertiary alcohol which can oxidize, this tertiary butyl alcohol. With so many efforts, it will undergo oxidation. KMnO4 heat, that is known as Drasidic condition, to give ketone with 1 carbon less, and this ketone will further oxidize to give this HCOH, that 2 carbons CH3COH. Now HCOH is the only acid with 1 CHO group, so this will convert into carbon dioxide and water. So these 3 are being the final product. What I said, this is the only carboxylic acid which is having aldehyde group. That's why it further undergoes oxidation. This is having aldehyde group, right? So oxidation is done and dusted. Clears? So just to let me know, how is the Josh? Thank you, Lingesh. Ambika ma'am is there. Is Ambika ma'am there? Ambika ma'am is there. Ma'am, just see, is there any sleepiness in my eyes? Just see my eyes. Is there any, even a single what to say, sign of sleepiness? Oh, where is ma'am? I can't see. I can't see Ambika ma'am. Kids, where is ma'am? Kids, do let me know. Sumitlaleen, where is ma'am? I made mistake in Popop's rule. Okay, let me check. Popop's rule. One kid is saying I made mistake. Let me check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So carbonyl group will go with that alkyl which is having less carbon. Popop's rule says carbonyl group will go with that carbon which is having less alkyl. So 2 carbon acid and 4 carbon acid. So it's absolutely correct. 2 carbon acid, 4 carbon. Popop's rule says what? Carbonyl group will go with that alkyl which has less carbons. So absolutely clear. It's Romba Sulbham. It's fantastic. Absolutely the correct thing I've told you. One kid was saying I did one mistake in pop-ups rule. No, it's absolutely correct. Got it, kids? Everyone just do let me know in the chat section. Everyone, Faisal, Siddiqui, and everyone just do let me know if it is clear. I want to see green hearts. Hey kids, Baba HSP want to see green hearts, and whatever the questions you are dealing with, same questions, definitely same questions will come in your examination. Don't worry, let him send whatever he want to send. Let him send, don't worry. Whatever anyone is sending doesn't matter. That's none of our business. You just do your business, right? Let them send. Now see, it's over and out. Now next thing is alcohol is done and dusted. Let's deal with ether. And ethers, the most important thing is cleavage of ether. Ether preparation we have done. The most important part in ether is where they are going to ask maximum questions, that is cleavage of ether. Remember that what I'm talking about. Most important thing is cleavage of ether. This is the most important part. It holds a hell lot of weightage. Maximum question will be asked from here. Maximum questions will be from here. Are you ready with full on Joes? Then only you can do the questions. Show me some fire in the chat section if you are ready, because this is very, very important. See kids, if I talk about ether is like this. Now you see here the leaving group is OR negative part. This is the leaving group. And this leaving group will not leave easily. Why not leave easily? It will not leave easily. Or you can say very, very poor leaving group. Why? What's there? Why it is very, very poor leaving group? What's there? Because it's a very, very strong base. Very, very strong base. Very, very strong base. Now kids can ask, how can you say that it's strong base? See, if I add H to this, it's a weak acid, and the weak acids, they form strong conjugate base. So they are inert for any reaction, will not show, will not react. And that's why ethers are being used as polar aprotic solvent, and this is the reason. That's why ethers are, and that's why ethers are used as polar aprotic solvent in the solvent industry. Now, sir, if they are not going to react, then why you have written that cleavage of ether, this and that? Why? What do you want to show, kids? If somebody is not reacting, then we will provide acidic condition, then it will start reacting. See, ethers will react with very, very strong acids like HI, HBr, because they are very, very strong acids. pK value, if I write down -10, -9, it's very, very strong acid. Now, how the reaction will take place, that is the important part, and just see to it. The most important thing I am going to tell you, just see to it, right? So that you can do all the questions easily. Once you add HI to it, now remember that HI is being acid and this is having lone pair, so definitely it will throw its lone proton. This proton will come and attack on the lone pair of oxygen. Then what you will get? You will get compound like this, O positive, H. Now oxygen will say, I can't tolerate this positive charge, because oxygen is very electronegative element. It can't tolerate this positive charge. So what will happen? Oxygen will try to snatch electron from this carbon and this carbon from left hand side and from right hand side, left hand side, right hand side. Oxygen will try to snatch electron, but do you think that carbon is ready to donate electrons? It all depends. If carbon is getting stabilized by resonance, or it is having, either of them is having at least 8 alpha hydrogen atoms. Sir, repeat, please repeat. Sir, once again, please repeat. Okay. If carbon, left hand side or right hand side, if carbon, these carbon, I am talking about the carbon directly attached with oxygen. If carbon is stabilized by resonance, or having at least 8 alpha hydrogen atoms, then SN1 reaction. Remember that then this is the most important point, kids. This will change your life. Then SN1 reaction, What I'm saying, kids, then SN1, and you know that in SN1 reaction carbocation will form. Carbocation formation. Takes place, and definitely the one who is forming carbocation, I negative, will attack on that carbocation. So carbocation will be attacked by I, right? So one question arises, so what will happen if carbocation is not stabilized by resonance or having alpha hydrogen? Then what is going to happen? Then gets SN2. If not SN1, if no SN1, then SN2. Remember that. If no SN1, then, if not SN1, then SN2 for sure. And then what will happen? I will tell you. If SN2 is going to take place, then what will happen? Okay. So let me write down on the next page what will happen if not SN1. So see, let me divide it. SN1, SN2. I negative will attack on carbocation and here I negative will attack on least sterically hindered carbon. So always think about SN1 first. If not SN1, then SN2 for sure. But first think about SN1. That is the most important point. Otherwise, you will get failed. First, think for SN1. If not SN1, then go for SN2. If not SN1, then go for SN2. Now, let me explain with the help of example. Otherwise, you won't be able to understand. Example number 1. This is allyl this is ethyl ether. Now HI, just think about what will happen, what is going to happen. Just think about. So see, the H plus will come and attack over here. So let me draw. H plus will come and attack over here. It will form oxonium ion like this. Now you can see this carbocation is stabilized by resonance. You can see this will do resonance. So SBR means stabilized by resonance. So this will go like this. The cleavage will be like this. So this got separated. It has formed alcohol. It has formed alcohol. Can you see this alcohol? OH CH2 CH3. This got separated out. This got separated out. So what part of this HI has been left? I negative has been left. So that I will come and attack over here. That's the thing which I have told you. So this will attack over there. So let me put here right now negative charge, and the product will be allyl iodide. Remember the name. Name is very, very important. Now, this was the first example. If the clarity is not there with the help of this first example, I will give you second example. Don't worry. Don't worry. Just see. Be happy. Example number 2. If I write down something like this, isopropyl methyl iodide, and I am writing HI to this. Now see, oxonium ion will get formed. Oxonium ion. This is the lone pair. This H plus will come and attack over here to form acid-base neutralization. Once acid-base ABN means acid-base neutralization has done, so you will get oxonium ion. See to it. Now, neither this carbocation is stabilized by resonance, nor that carbocation is stabilized by resonance. No, it's not stable. That is not stable. Then what is going to happen? Then I negative will come and attack on least sterically hindered carbon. This is least sterically hindered, and this is too much sterically hindered. So this is least sterically hindered. So I will come and attack over here. So this will separate out with I negative. So this will form alcohol than that. So this is your result. Now kids, it has taken near about 1 to 2 minutes. In the examination, if you don't want to spend these 2 minutes, then you can solve it just in fraction of seconds. I'm going to tell you that also. Same question, let's see with fraction of second. Just see. Trick. HSP trick will give rank to each and every one. Just chemistry is in the air. Chemistry is in the air. You have to see to it. Just see. Neither this carbocation is stable nor that carbocation, then definitely I negative will attack on least sterically hindered and H will attack over here. So what product you will get? You will get this one's iodide and this one's alcohol. That simple as it is. As simple as it is. Just see, these are the two products. Are you happy now? Just see, it's SN2 reaction, ABN first acid base neutralization and then SN2. So it has given you alcohol that has formed iodide. Simple, very simple kids. Now you got it. Now the SN1 also you can get in single steps. SN1 also, see example number 3. Let me show you. C6H5 CH2 O CH2 CH3. Now you can see if you reacted with HI, this carbocation, can you see, is stabilized by resonance. So carbocation, that means in SN1 reaction, I will go to carbocation, then H will go to that. So once again, this product is simple. I hope that everyone is enjoying it. It's not a tough thing, not a hard nut to be cracked. It's simple. Some people will definitely get full marks once they are able to understand it. I hope this is clear to each and everyone. Just see to it and do let me know in the chat section. Clear kids? Do let me know in the chat section. How is the Josh? Till now there is no sleepiness in my eyes. You can see no sleepiness. Baba is fully enthusiastic, full of enthusiasm. Now kids, now ethers completed each and everything I have told you. You made mistake in Popoff's rule in tertiary alcohol slide. Tertiary alcohol slide. Okay, let me see. Wait. One kid is continuously writing, so let me see where he's talking about. Tertiary alcohol, just wait. Where is the tertiary alcohol? Where the tertiary alcohol has gone? I to know very well that I taught you, but where it has gone? Tertiary alcohol slide. Okay, he must be talking about here. This place, you are talking about this place. Do let me know, you are talking about this slide. Are you talking about this slide? Do let me know, you are talking about this slide. Are you talking about this slide, kid? Just to let me know. Okay, you are talking about this slide only. See, it's right. Just check it. This tertiary alcohol, just see. This is tertiary alcohol. When you react with KMnO4, tertiary alcohols, 4 carbon atoms will give you a ketone with lesser carbon atom. 1 carbon will convert into carbon dioxide. So 3 carbon atom. It is absolutely clear. Correct. Here there is no Popov's rule. Popov's rule is applicable on ketones. Now see, this is carbonyl group. This is carbonyl group. Now this carbonyl group can go with this carbon or that carbon. See why? If it is going with that, it is having 1 carbon. If it is coming with this, it is having 1 carbon. So both sides, they are having same carbon. So it's eliminated out. Got it, kids? No mistake. Tertiary alcohol will give ketone with 1 carbon less. Now Popov's rule will be applicable over here. Popov's rule says that carbonyl group will go to that carbon which is having less number of carbon. This side also same, this side also same. So it has gone. So 2 carbon acid, 1 carbon acid. Got it? It's absolutely clear. Nothing wrong. Now tell me you got it or not. In the chat, everyone do let me know. Nothing is, no mistake is there, right? First of all, do let me know. Do let me know in the chat section. Are you able to understand, kiddo kid? Yeah, break I will give. First, do let me know you when that kid has got it or not. Is it clear that kid has got it or not? Arey kids, got it. Okay, okay, okay. See, this is your Baba HSP. This is your Baba HSP. Can you see now, kids? Right now, it's 12. Now, kids, the chapter aldehyde ketone is very, very important. Means I can say 4 to 5 questions definitely, either from this or there, because Aldol, Cannizzaro, Iodoform test, this is a lengthy one and this holds a hell lot of weightage. Tolerance test, Fallings test, number of questions you will be able to do once this chapter is completed. So kids, how much is your energy level? What your energy level says? My energy is full on. Full 38 ATPs or whatever the ATPs, eukaryotic, prokaryotic, I don't know, glucose, glycolysis, 10, then -2, 8, acetyl coenzyme, citric acid, cis-aconitic acid, isocitric acid, alpha ketogluteric acid, succinic, fumaric, malic acetyl coenzyme. I don't know anything. I don't know anything. But tell me, how is the energy level, kids? It's high. So let's meet at what time? Do let me know. Let's meet at what time? Wow, 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 wow. 100%. So let's meet at 12:20. Let's meet at 12:20, right? 12:20, right? 12:20 a.m. or p.m.? 12:20 a.m. or p.m.? a.m. So let's meet. Let's meet with full on energy. Okay, let's meet with maximum energy. Remember that, full on energy. Welcome back again, kids. Are you back? I'm in time. Just see 12:20. See once again. Still with full on energy, kids. With full on energy. Chaitanya Mashkare, Sahana, Bye, Perfecto Mercapto. Wow, that's really fantastic. Sai Chiranjeevi, everyone just do let me know, are you back? So we are going to start with aldehyde and ketones, the most important chapter which holds a hell lot of weightage. So let me see everyone, are you back? Show me the green hearts along with fire. The chat should run very fast, speedily, kids. Speedily, the chat should run speedily. I want to see. Oh, thank you, Krishnakant. Thank you. So let's it go. I want to see green, along with fire in the chat section. So now let me tell you the flow of this aldehyde and ketones. Chapter here is aldehyde and ketones. And let me tell you, kids, how we are going to cover this aldehyde and ketones, right? Aldehyde and ketones. First, I will tell you name reactions. Then distinguishing tests. And then I will tell you preparation and chemical reactions in the sequence, right? First, what I will tell you, kids? First, name reactions. Then the distinguishing tests. And then preparations and chemical reactions. Right? We will move like this, in this way, right? This is the flow, kids. We will go like this. Is it clear? Because these two are very, very important. These two things, you can say, very, very important. Very, very important. This is the flow, right, kids? Is it clear? Are you there with full on Josh? Let me see, kids. Hey, show me fire if the energy is high. Fire. I'm going to start and I will tell you the tricks along with each and everything in detail. Waiting for my iodoform phalanx test. Okay. That's fantastic. Okay, that's really awesome. After that, I will deal with carboxylic acid and derivatives. Okay, carboxylic acid and derivatives. Okay, so in this only it will get cleared. In this only, aldehyde ketones and carboxylic acids will get cleared here only, and carboxylic acid also, and derivative, then carboxylic acid will come here only. Carboxylic acid will come here only, right? Okay, Now let's it go. First name reaction's name is aldol condensation. So I'm going to tell you what? Aldol formation and condensation. Formation and condensation. Aldol formation and condensation. Very, very important. Right, kids? Aldol formation and condensation. This is very, very important. So I will give 15 star. How many stars to this? 15 star reaction. 15 star reaction. It's very, very important. So 15 star reaction. I don't know how many stars, but let's say 15 stars, right? It's very, very important. It will take some time, right? It will take some time. So you have to sit with peace of mind, with patience. Now see, if I tell you in simple words, it will look like very simple. This reaction will definitely look like it's really very simple. Just see. Who can show this reaction? Who can show this reaction, right? Aldehydes or ketones having at least two acidic alpha hydrogen atoms, on reaction with dilute alkali. Now in dilute alkali, what they can give? Just remember that they can give you number of things, so take care. They can give you NaOH, they can give you KOH, they can give you RONA, or they can give you ROK, anything like this. And once they have given very interesting thing like Br negative and BrO3 negative plus water. Now this, there is no OH, so remember that this is opposite of disproportionation reaction. This will give you what? Br2 plus OH negative. So OH negative is required. These are the combinations we should remember, we should know. Let me see what's going on in the chat section. It's okay, kids, and hit the like button. Make it 500. It's not 500. Yeah, it's 546. So make it 600, right? Make it 600. Now see, kids. Now first I will tell you the short trick. Then I will tell you in detail. Short trick. Just see Baba HSP short trick. That CH3 CH double bond O, it's given like this. So see, alpha hydrogens, two acidic alpha hydrogens will eliminate out in the form of water to give the product. So water will eliminate out, right? So your answer will be CH3 CH double bond CH CH double bond O. I think it's clear to each and everyone. And if you see this is carbonyl group, adjacent is alpha, beta. This is the products identification. That product must be alpha, beta unsaturated aldehyde or ketone. and its name is well-known name croton aldehyde. Croton aldehyde. So remember it. It's croton aldehyde. Right? Now let's see the mechanism, because mechanism is very important. That only give you mechanism of aldol condensation holds a hell lot of weightage. So let's see. Let's focus on the mechanism. Dilute NaOH will break down to give Na positive, OH negative. Now the OH negative can act as base or it can behave as nucleophile. It's both base as well as nucleophile. No need to cram, just focus on the fundamental thing. So it can behave as both, but first preference should be given to this base. First preference. So whenever it is going to see this aldehyde, this aldehyde is having acidic alpha hydrogen as well as this carbonyl group. So 2 points of attack are there, either this one or this one. So this, if it is going to react over here, it will be known as nucleophile. If it is going to react here, it will be known as base. So first preference should be given to acid base neutralization, because it is fast reaction. Acid base neutralization will take place, my dear students. ABN means acid base neutralization, and you will get carbon ion. So first formation of carbon ion, and that will do resonance. So enolate will get converted into enolate also, like this. CH2 by tautomerization, double bond CH, O negative, enolate. It will live like this. Now by seeing this, the second molecule of aldehyde will convert into like this, because we know that it's CH3, CH double bond O, it is partial negative, it is partial positive. So it can convert into like this, CH3, C positive, O negative, and H. Now see, this is the point to be noted, my lord, that here carbon-carbon new bond formation will take place. Carbon-carbon new bond formation will take place like this. Carbon-carbon. Examiner will ask that carbon-carbon new bond formation takes place or not. So remember that carbon-carbon new bond formation will take place, and this is the point to be noted, everyone. Now see, CH3, CH O negative, and this new bond formation is like this, new bond formation is like this, and then CH2, CH2, these, let me take another pen, CH2 and CHO. Now in the starting it has formed HOH. Now this was NaOH, so NaOH will come to this HOH, HOH, and Na plus will come and will say, give me back my OH negative, right? So H plus will remain in the solution, and this H plus will come over here. So this is known as aldol. Remember that this is aldol. How to find out aldol? See, aldehydes, ald and all, OH all. Now this bond, remember that. What is the identification of aldol? This is the carbonyl group, this is alpha carbon, and this is beta hydroxy. Always remember that aldol is beta hydroxy aldehyde or ketone. Aldehyde or ketone. Remember this point, my lord. Now whenever, suppose they have given you aldol and they are in need of the normal reactant, you should know how to break it, how to go back. So remember that from beta, remove H and break this bond. Break this bond and give this H to alpha. From beta to alpha, just give from beta to alpha. Is it clear? Now this much is clear. Now how the further reaction will take place, that let me show you. This is aldol, and how the condensation will take place. CH3, CH2, CH2. This was CHO. So CH3, COH, CH2, CH double bond O, beta hydroxy. One thing is that you can remove from alpha this H and from beta this OH directly. It's like this, negative, positive. No, here it's positive, there it's negative. Alpha, beta. Here this is alpha, this is beta. This will go to give plus charge and this will go to give negative charge. Bond will form. But actually direct reaction is not possible. Direct reaction is not possible. We write it directly, but actually, you know, this is poor leaving group. So it will not go easily. How actually the reaction takes place? OH negative will come once again and take away this proton. So partial negative charge, CH3, CHOH, CH negative, and CH double bond O. This is conjugate base. So it is acting as an acid, and this is acting as conjugate base. Now this electron will start coming to this side, and the repulsion, due to electronic repulsion, this bond will become weak. Now Na plus and OH negative will go, and this mechanism is known as E1CB, but not in syllabus. This name is not in syllabus. That's now it will go and it will give final product like this. So this is the final product. Is it clear? Now if it is clear, the mechanism is clear, I will give question, right? Ready everyone? Is everyone ready for the question? Just see the question. If I give you this question, CH3, CH2, CH double bond O, it's written like this, and dilute NaOH plus heat, what should be your product? Just think over it, then I will write down the product and you have to tell me that your product was like this only. Okay, so this was the question. I am writing down the product. CH3, CH2, CH double bond CH, CH2, CHO. How many of you got this product? Just see to it. Is this your product or not? Let me know in the chat. Is this your product or not? Do let me know in the chats. Is this your product or not, kids? Fast. Do let me know in the chats. Is this your product or not? No one is writing. Just do let me know. Is this your product or not? Now see, you got trapped. See why you got trapped. This is wrong answer. You got trapped by Baba HSP. See kids, why it is wrong? This is alpha, this is beta, this is gamma. I have told you alpha, beta. So this is wrong. Absolutely wrong, kids. Now what mistake is done by you, kids? Let me show you the mistake done by you people. Should I tell you the mistake? Just see. CH3, CH2, CH double bond O, it is in need of acidic alpha hydrogen, so it will be like this. This is acidic alpha hydrogen atom, and it will go, not all the hydrogens, these hydrogens will eliminate out. So your product will be, kids, your product will be CH3, CH2, CH double bond C, CH3, CH double bond O. Now alpha beta, just see, this is alpha, this is beta. Now this is the correct answer. This is one is the correct answer. I hope everyone got it. Got it, kids? Now one question which generally most of the examiners they ask. Let me show you that question, just see to it. Very, very important question. If they give you question like this, that CH3 CHO N molecules plus CH3 C double bond O CH3 N molecules. N molecules means maximum molecules. Now this is acetaldehyde, that is acetone. Dilute NaOH and heat. Now they are asking, question is, how many types of aldol condensation products will be obtained? Question is, how many types of aldol condensation products will be obtained? How many types of aldol condensation products? Just tell me your answer. Option A is 4, B is 3, C is 2, D is 10. Which option you will go for? You will go for which option? Let me see the chats. Which option you will go for? Do let me know. Srushti is going for 4A. Everyone correct. That's really fantastic. Your answer is correct. That means you know this. 2 self aldol and 2 cross aldol, right? 2 self aldol and 2 cross aldol. That's really fantastic. No need of explanation is required. Everyone clear? Now, next question. Now, if they give you, this is rank deciding question, rank deciding. If they give you question like CH3CHO 1 equivalent HCHO 1 equivalent dilute NaOH, what should be the answer? Dilute NaOH, what should be the answer? How will you do this question, kids? How will you do this question? Now let's see. We know that this is having 3 acidic alpha hydrogen atoms, right? This is without alpha hydrogen atom, without alpha hydrogen atom. So definitely OH will come to this compound. It will snatch its protons, so you will get CH2 negative. Now this has formed carbon ion and that will become carbocation. Just see, carbocation HC positive H. Now carbon new bond formation. Remember that. This is the point to be noted, my lord. Carbon new bond formation. Carbon new bond formation. So what do you will get? You will get compound like this, CH2 CH double bond O and CH2 OH. This is aldol, alpha, beta. So it has lost one acidic HN. In place of that, it has gained what? It has gained CH2OH. Remember that in place of one acidic hydrogen, it has got CH2OH. Is it clear, kids? Is it clear? Now, if the question would have been like this, just see to it. The question would have been like this. CH3 CHO 1 equivalent and formaldehydes 3 equivalent HCHO 3 equivalents, dilute NaOH or barium hydroxide, what should be the answer? Just think about it, then I will write down the product. Just everyone think about it, and then definitely I am going to write down the product. Now see, it is having 3 acidic alpha hydrogen. The earlier one, whatever has happened, it will lose 3 acidic H and it will get 3 CH2OH. Just if you see this reaction, by losing 1 acidic H, it has gained 1 CH2OH. So it is having 3 acidic H. So in place of 3 acidic H, it will gain what? It will gain 3 CH2OH. 3 CH2OH. So once, then twice, and then thrice. So this will be your answer, kids, right? Now, after this, I'm going to tell you the intramolecular aldol condensation. Is everyone ready for intramolecular aldol condensation? Intramolecular. Now just focus on how to do that intramolecular. Suppose if the examiner has given you this question, 1, so this one, and it's like this. Now how to think about, you will do the reaction. So you know that aldehydes being more reactive, this will act as carbocation and its acidic hydrogen. If this acidic hydrogen, alpha hydrogen near to this alpha, and this is also alpha, these 3 hydrogens. Now if it is forming bond, then how many carbons ring? 1, 2, 3, 4, no. And if it is going to react, 1, 2, 3, 4, 5, 6. So definitely what will happen? This will react with these 2 hydrogens. You can see that will react with these 2 hydrogens, and these will eliminate out in this way. So we have eliminated out water through that trick. But how to form the product? How to write down the product? So what you are supposed to do? Just do one thing. Write down A, B, C, D, E, F. So you formed ring of 6 carbon atoms. Anywhere you can write down A, B, C, D, E, F. Doesn't matter, right? A, B, C, D, E, F. Anywhere you can write down A, B, C, D, E, F. Randomly you can write down anywhere. But where you have formed the bond? In between A and F. Right now you have formed one bond in between A and F. A and F. So where is A and F? This is the new, this is one bond and one more bond. See, this new bond has been formed in between A and F. So what is attached? This double bond. Can you see? Double bond has been formed. So I have written double bond. Now what is attached on E? Carbonyl group. So on E, write down carbonyl group. Now D nothing, C nothing, B nothing, nothing. So it is the product. Let me check it out. It's right or wrong. Alpha beta unsaturated carbonyl. So this is the answer. How many of you got it? Do let me know in the chats how many of you got it. If you're not understood, do let me know. I will explain it again. Now do let me know, everyone, how many of you got it? Fast, fast, kids, fast. I think you got tired. You got tired. You got tired, but see my eyes. No sleepy, not feeling even a single drop of sleepiness. No, kids, you got it. Now let me give you one question. Let me give you one question. Question is, Find out what is C. Everyone, find out what is being C. It's a question. Let me see in the chats what's being C. Everyone. What's being C? Now I am forming the product. Just check it out that your product is getting matched with what I am going to write. Okay. So see H2SO4, that this will be cyclohexene. Am I right? Dehydration, acidic dehydration. Now ozonolysis will break the bond from here. Will break the bond from here. You will get CHO CHO. Now after that aldol condensation. Now how to do that aldol condensation? Just see. Let me write down over here. It will remove two hydrogens. It will remove these two acidic hydrogens to form water. Now it will form a bond. Alpha beta. This is your product. I hope that everyone got it. Everyone, it is clear. Now let me tell you two aldol condensations which are very, very important. Aldol condensation in acidic medium. In acidic medium. Remember that acetone CH3 COCH3, if you treat it with dry HCl, it will form 4-on, the major, this is a polymer, plus acetyl oxide as minor product. Now how will you form it? Just see. For 4-on, 3 molecules of acetone will react so in this way you will get 4-on. Just remember that we have to eliminate out water. Now the product could be written like this: CH3 C double bond CH, C double bond O, CH double bond C, CH3. This is your 4-on, right? 3 molecules, 2 moles of water has been eliminated. Now how to write down acetyl oxide? This is also very, very important. So 2 moles of acetone this is your acetyl oxide. This one is your acetyl oxide. Remember the name, very, very important. The journal names, they hold a lot of weightage. This name, these 2 names are very, very important. I hope this is clear. Let me see, kids. Everyone, you must be feeling sleepy now. Are you feeling sleepy? Kids, just enjoy the process. Don't think about when the class will get over. Kids, how many of you will remain up to the last? Just to let me know. चैतन्य नहीं मैं जल्दी ख़त्म कर दूंगा क्लास 7:30 नहीं. Definitely I will just at 3 or 4. Not I will, and it will not go beyond 4. Maximum 4. Maximum 4 a.m. Show me the green hearts and the fire if you are with full on energy, kids, and say that you are not going to leave it in between, kids. It will not go maximum 4, right? 4. Maximum is 4. Maximum is 4. 4 a.m., right? Okay. So let's see. This is over and out, and reaction with H2SO4 when this acetone is going to react with H2SO4. What product you will get, kids? See. See, kids. It will form mesitylene. What should be the product? That was mesyl oxide and its name is mesitylene. What is the name? Mesitylene. Just remember mesitylene. Mesitylene is the product. Now, I've told you each and everything about aldol condensation in detail, right? In detail I've told you, right? Now, let's set go with one question for you people. If they give you question like this, one question like this, and another question like this, now what should be your answer? What should be your answer? So definitely just see to the first one how to do it. Just remove water from the alpha hydrogen, just one. So your answer will be now cross check it whether it is alpha beta or not. Double bonded alpha and beta. This is right. Now here the ozonolysis will break this bond. Now this oxygen, so all there are alpha hydrogen. This is alpha hydrogen, this is alpha hydrogen, these two are alpha hydrogens, these two are also alpha hydrogen, these two are also alpha hydrogen. So remove anyone from anywhere. Let's suppose remove these two alpha hydrogens with that. So your product will be One is 5-membered ring, another one is 7-membered ring. One is 5-membered ring, another one is 7-membered ring. Just check it out, and it's swing alpha beta. Both the two products are clear. Let me see in the chat section. Everyone is able to understand or not? It's got it? Are you getting it? Now, after this, I am going to tell you Cannizzaro reaction, okay? Which one? Gau, Sankradev, which one? The B1. Okay, let me repeat the B1. Don't worry, kids. Let me repeat this. Let me repeat the B1. This is double bond O. This is double bond O. Just see this adjacent to this carbon is alpha carbon. Just remove water. Just remove water. Now they will form a bond. Now I hope it's getting clear or not. The bond has been formed here. Now check. Now check you got it or not. This is alpha, this is beta. Alpha, beta, unsaturated. Now you got it. Now do let me know in the chats. Everyone got it. Now understood. It's clearly visible. Do let me know in the chats. If yes, show me green hearts that yes, this time you got it. Everyone, kids, everyone, just do let me know you got it or not. Very good, Sahana. Very good. Very good, Tharun. Casper. Madhuliha. Casper. Yes, you got it. Now, let's see Cannizzaro reaction. After this, let's see the Cannizzaro reaction. Very, very important reaction. What happened? Where they have gone? Cannizzaro, 15 stars. Very, very important reaction. Cannizzaro. Hey everyone. This is also having so many stars. 15 star reaction means very, very important reaction. Very, very important reaction. 15 stars, right? Now see, this reaction is what happens over here. 2 moles of RCHO, 2 moles of RCHO, but these aldehydes should be without alpha hydrogens, without alpha hydrogens, and here concentrated alkali is required, that they will react with concentrated alkali. One molecule will undergo oxidation. One molecule will undergo oxidation. Another molecule will undergo reduction. Another molecule will undergo reduction. Now see, that's why this is known as disproportionation reaction. This is disproportionation or redox reaction. Now if you find out the oxidation number of this carbon, it's 0 oxidation state. Here it is +2 oxidation state, and here it is -2. So if you see from here to there, from here to this one, undergoing oxidation, and if you see in this one, it is undergoing reduction. So oxidation and reduction both are taking place. So easily you can find out the answer, kids, right? Are you getting my point, everyone? Now, how this reaction has taken place, let me show you the mechanism also, kids. Let me show you the mechanism by how this reaction is taking place. That's very, very important thing, very, very important point also. So we should know the mechanism, right? Mechanism of this reaction, because whatever the reactions mechanism I'm going to write, they are important, right? Whatever the reactions mechanism I'm going to write, they are important. Now see, mechanism. This mechanism will give the answer of number of questions. Why ketones do not show Cannizzaro reaction, why the more reactive aldehyde will undergo oxidation and the less reactive will undergo reduction, and why concentrated alkali is required. To give the answer to these three questions, we should know the mechanism, otherwise we will never be able to understand. Now see, concentrated NaOH will give you Na positive plus OH negative. Now we are having an aldehyde without alpha hydrogen, like if I take HCHO, this is not having any alpha hydrogen, so can't show acid base reaction. No acid base reaction, no acid base reaction, because no acidic hydrogen, no acidic hydrogen, so no acid base reaction, right? No acid base reaction. So that will attack over here, it will, OH negative will come and attack at this place, will attack over here as a nucleophile, acting as nucleophile. So bond formation. Now just remember that if it would not be concentrated, so no further reaction is going to take place. That's why we need concentrated NaOH, because this reaction is very slow, nucleophilic reaction. It is acting as nucleophile. If we are not going to use concentrated NaOH, then the reaction will not go in the forward direction, and we are using concentrated. That means more amount than Lee-Chatelier principle says. If anything is reversible, and if you are adding more reactant, reaction will move in the forward direction. So you will get HCO negative and 1 OH will added over here. This one is okay. Now what will happen? The second molecule of formaldehyde, HCHO, delta positive and delta negative. Now what is going to happen, kids? Because the reaction cannot go in the backward direction, so this compound will transfer its hydride. You know, hydride is not stable. Hydride will go to this compound, and hydride transfer is a very, very slow process. It's not easy job. So it is slowest step RDS. Slowest step RDS, rate determining step. How many molecules are involved? 1, 2, 3. And that's why R is equal to K aldehyde. How many aldehyde? 2 aldehydes power 2 OH negative 1. So the order of reaction is 3. Overall order is 3. Chemical kinetics, overall order of reaction is 3. Third order kinetics. Now hydride will come to this. After losing hydride, this plus minus will form HCOOH, and this while getting it will form CH3O minus. Now it's very simple. It will release its proton, and that proton will come to this one. So this will react with Na. It will form HCOONA, and this will convert into CH3OH. So these are the two final products. In this way, the reaction has got completed. And you know that whenever there are two different types of aldehyde, then who is undergoing oxidation? This is undergoing oxidation. Now, if I take one formaldehyde and one benzaldehyde, then who's more reactive? Formaldehyde. Then OH negative will attack on the one who is more reactive, and the more reactive will lose hydride, that is oxidation. So always in case of cross Cannizzaro reaction, it is the more reactive part which will undergo oxidation, Suppose if anyone is taking this cross Cannizzaro reaction, so if you are taking benzaldehyde without alpha hydrogen, formaldehyde without alpha hydrogen, so definitely this is more reactive. The one who is more reactive will undergo oxidation. More reactive, less reactive. So more reactive will undergo oxidation. So definitely this will undergo oxidation. Another one will undergo reduction. So you will get benzyl alcohol, reduced part, and salt of carboxylic acid. This is oxidized part. I hope this is clear. Now, very good question I am going to give you. But first of all, do let me know in the chat section that everyone is okay. Everyone is able to understand. Do let me know till now it's clear, fit and fine. It's fit and fine. Do let me know in the chats. Still there is no sleepiness, no sleep in my eyes. Can you see, kids? No sleep in my eyes. Just see my eyes. No sleep in my eyes, kids. Arey, let them do whatever they want to do. Don't focus. Just have patience and let's move with this, right? Now, the reaction is like this. CH3 CHO1 equivalent and HCHO4 equivalents. What should be the product? So this question is rank deciding. Now, in aldol formation, we have done 3 times aldol formation. If you remember, 3 times aldol formation, thrice aldol formation, so we got this compound there over there. Now, neither this is having alpha hydrogen nor that is having alpha hydrogen. No one is having alpha hydrogen. See, no alpha hydrogen. No alpha hydrogen. So, this is sterically hindered. So, this will undergo oxidation or reduction. This will undergo oxidation and this will undergo reduction. So, CHO part will also convert into CH2OH. This will also convert into CH2OH. This part will also convert into CH2OH. Already 3 CH2OH are there. So, carbon, CH2OH, 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 CH2OH. This is the product. Awesome product. So this is all about Cannizzaro reaction. Now I am going to tell you, yes, distinguishing test. Till now it's okay, everyone. Now see distinguishing tests. In these distinguishing tests, the tests which we will study, they are very, very important. What are they? Let me tell you. Tollens test, very, very important. Phalanx test. Oh. Phalanx test. Let me see this time what it's writing. Yeah, this time okay. Benedict's test. Benedict's test. Skip's test. Okay. These are the 4 most important tests, and out of these 4, the starting 2 holds a hell lot of weightage. Very, very important. So let me give stars to these. These 2 are very, very important, right? These 2 are very, very important. So how's the Josh? Do let me know in the chat, because these, once you know these tests, you can do a lot. You can do number of questions, kids, number of questions. Now are you ready? Everyone, just to let me know, is everyone ready? I want to see in the chat. I want to see some fire in the chat. These are very distinct. I think whatever is written distinct, I see it's wrong. Distinct. What is this distinguishing? Which English it is distinguishing? Wrong. Distinguishing test, right? Now, so let's start with tolerance test, which holds a hell lot of weightage. Tolerance test. Ready, steady, go. So let's see what is tolerance reagent. Anyone who can tell me what is tolerance reagent? Tolerance reagent is, remember that, tolerance reagent is an ammonical silver nitrate solution. An ammonical silver nitrate solution. An ammonical silver nitrate solution means what? AgNO3 plus ammonium hydroxide, and this will give you AgNH3 OH, or this can also be written like this: AgNH3 whole twice positive, and sometimes it can also be written like this: Ag2O. Everywhere the most important thing is that it is argentous, Ag plus, and it is in need of one electron. The main thing is that Ag plus is in need of one electron. From somewhere it is going to snatch that electron. From where it can snatch this electron? See, from where it can snatch? Ag plus can snatch one electron from aldehyde. It can snatch electron from aldehyde. This is reactive. So aldehyde will donate one electron easily. So by taking that electron, this Ag plus will convert into what? By taking one electron, Ag will become, silver cation will become Ag, and this looks bright shining silver mirror. This looks what? Bright shining silver mirror. Bright shining silver mirror. Bright shining silver mirror, and this will oxidize to aldehydic part. This will aldehyde will go to acidic part. So it is undergoing reduction, and that is undergoing oxidation. One is undergoing oxidation and this is undergoing reduction. So it's a redox reaction. It's a redox totally. It's a redox reaction. Redox reaction. Now you're not able to understand anything, so let me write down on the next page. See properly in this way. You have seen this is aldehyde. You always see reactions in this way. This is tolerance reagent. So the aldehyde will undergo oxidation and this will form silver mirror. Ammonia and water will eliminate out. So it is an example of redox reaction. Bright shining silver mirror appearance shows that test is positive. Now which compound will give this test? Are you okay? Just to let me know in the chat section you are able to understand. Kids. Wow, that's really Supra. Shubha Sridas, welcome. Everyone, just to let me know, till now it's fit and fine, everyone. Wow, Sahana with full on energy, Tharun is with full of Fatima, Janvi, Madhuliha, wow, Gau, Sankradev, Sanju, Harni Reddy, Chaitanya, Baba, you too good. Vishal MH, really? Afifa Sheikh, wow, my HSP and army is there. Really feeling good by seeing these kids, HSP and army kids. Really awesome. Baba is so happy. Now make it 600 likes or 585. Then I am going to tell you. Put 15 likes. Make it 600 kids. Not required. Sahana, IUPAC of that is not required. Not in syllabus. Thank you, Nadia Khan. 2,4 DNP test. Yes. I will teach reactions and 2,4 DNP test also. Oh, Vishal, that's really awesome. So great, kids. So great. So nice of you. Okay. So let's sit. Let me tell you the reactants, the type of. Now see, ketones will not give this test. Ketones are inert towards this test. No reaction, no color, no silver mirror. Right? Now, compounds which will give this test, this is very important, kids. Compounds which give positive tolerance test TT. We can write down TT for tolerance test. We can write down TT for tolerance test, right? So first is aliphatic as well as aromatic aldehydes. Aliphatic and aromatic aldehydes. Second is, on second number, it's N-phenyl hydroxylamine. Third number, all monosaccharides. Like glucose, fructose. Now when you see fructose, one question will come to your brain because you are intelligent. Mannose, galactose, etc., etc. Now this fructose is a ketone. This question will come to your brain. It's ketohexose. So ketone, why this is going to give this test? This question will definitely, you will ask, sir, why this is giving this test? So let me answer it, okay? Whenever we are having fructose or any molecule like this, alpha hydroxyketone, any molecule like this, alpha hydroxyketone. This is alpha. All alpha hydroxyketones will also give this test. Why they are going to give this test? You see, the medium is basic AgNO3 ammonium hydroxide. So tautomerization will take place. 1, 2, 3. This hydrogen will come over here and this double bond will go over there. Tautomerization. You must have heard the name tautomerization. Tautomerization. So what you will get? You will get CHOH double bond C OH, yes, R. Now once again tautomerization will take place. Now 1, 2, 3. This will come, this hydrogen will come over here and this will go over there. So what you will get, two possibilities are there. One possibility is being CH double bond O, CHOHR and plus, because this is sp2 hybridized. So this H can come from left hand side or can come from right hand side. It can come from any side. So CH double bond O, CHOHR. One is glucose, another one is mannose. So actually this reaction is given by aldehyde only. Whatever is written in NCERT that aldehyde gives this reaction. This is another thing that ketones first got converted into aldehyde and then they have given this reaction. This whole process is known as Lowry-de-Brown Van Akenstein rearrangement. Akenstein rearrangement. Lowry-de-Brown Van Akenstein rearrangement. So all fructose means all alpha hydroxy ketones Otherwise, ketones do not give this reaction, but all alpha hydroxy ketones will give this test. So, how many compounds I have written till now? 3 types of compounds. Now, 4th type of compound. Disaccharides, all disaccharides, saccharides except sucrose and trehalose. Now, 5th type, all hemiacetals. What are hemiacetal kits? CH3, CHOH and OH. Now, 6th, formic acid. What is there in formic acid that it's going to give this test? What is there? Just see. CHO is there. 7th, all alkynes with terminal triple bond. But remember that here you will not get silver mirror. What you will get then? You will get white PPT. Remember that you will get white PPT of silver acetylide. You will get white PPT. All the compounds I have written. Let me see in the chat section, kids. Now, people, I think people are sleepy. People are sleepy now. So, strength, people, rest of the people, just to let me know. Thank you, Ishika Kesharwani. Thank you. Oh, Vishal, thank you, thank you, thank you. Afifa Sheikh, thank you, thank you, thank you. Right. Sahana, Afifa, Vishal, number of students they are. But see, no, not a single sign of sleep in my eyes. Now, tolerance test is clear. Now, let me tell you, Falling's test. Now, Falling's solution, first of all, we have to see Falling's solution. Falling's A and Falling's B. Falling's A is CuSO4 dot 5 times H2O aqueous solution. Falling's B is Rossel salt. That is sodium, potassium, tartrate plus basic medium. Now these two will freshly prepared and they are heated. These two are freshly prepared, first of all freshly prepared, and it will give CuOH whole twice. It can be written like this, right? So ultimately the thing is that it can be written like CuO, that means Cu2 plus is important thing, Cu2 plus. It can be written like this also, CuNH3 whole 4 OH whole twice. So it's freshly prepared. By combining this, you will get that. Okay. Now, only the difference is that benzaldehyde will not give this test. Only aliphatic aldehydes will give this test. Tolerance test, from where we have got tolerance test? It was phalanx test. So let me take another page for phalanx test. Only the difference is that only aliphatic aldehydes will give this test. Only aliphatic aldehydes will give this test. Benzaldehyde will not give this test. Remember that benzaldehyde, very, very important point. Now another thing is that why benzaldehyde will not give this test? First question, let's see. If you see the SRP value of CO2 plus and Ag plus, this is in increasing order like this, the SRP value. So silver plus can snatch electron from aromatic aldehyde, but CO2 plus can't snatch. And what color you will get, that also let me tell you. So if you, and this is once again phalanx only, RCHO, the aliphatic aldehyde, remember that aliphatic only, once again I am telling you, only aliphatic, plus Cu NH3 whole 4, heat it, you will get red color. Red color, see, this is Cu2 plus. From Cu2 plus, if it is gaining one electron, so it will convert into Cu2O, cuprous oxide. This is reddish brown color. Remember this, reddish brown. Once again, it's being also redox reaction. And note, Benedict's is same like this. Benedict is same like this. Phalanx, only what's the difference in Benedict's? Difference is that phalanx, sorry, Benedict's B is, difference is Benedict's B is sodium potassium citrate. There it was tartrate, here it is sodium potassium citrate. That's it, citrate, sodium potassium citrate. Now what is Skip's test? Skip's test, and Skip's test I'm going to tell you, kids. It's very simple, one line. Skip's test. Skip's test is that when aliphatic aldehyde reacts with Sip's reagent, what is Sip's reagent? It's rosa aniline hydrochloride. It restores pink color. It restores pink color, means pink color will develop. First develop, then go, and then permanent it will come. Restores pink color. Okay. Now let me see the chats. Very good, kids. That's really fantastic. What I can see, number of students are watching, and this is your energy level. That's why, kids, I have full faith on you. Full faith on you, kids. Now, once the distinguishing test, these mild oxidizing agents, now two more distinguishing tests, one iodoform test and one 2,4-DNP test. Two more tests I'm going to tell you, kids. So iodoform test is a lengthy one. Iodoform test is a lengthy one. Are you ready, kids? Iodoform test. This is very, very important. Very, very important. Let me tell you, kids, it's very, very important. Number of stars I have to give to this. Number of stars, very, very important. Very, very important. No exam can come or go without this. Very, very important. So ready? So the starting compound for this is RCH OH CH3 or RC double bond O CH3. These are the compounds. Why these are the compounds? Very, very important compounds. These holds a hell lot of weightage. Why these compounds will give this test? I will show you the mechanism and then you will come to know why I'm saying this. Are you ready, kids? Are you ready? Let me see the chat section that everyone is ready. Make it 600. Likes are 595. Why they are at 597? Only 3 likes more. Gonna ready, Chaitanya. Very good. Sahana, Janvi, wow, kids, that's awesome. That's awesome. That's really awesome. Now see, let me show you the whole mechanism, how the reaction will move on. How the reaction will move on. Kids, wow, kids, thank you, thank you. Iodoform test. Let's see. See the mechanism, kids. R C H OH CH3. Once again I am writing. It's not looking good. That's why again I am writing, kids. R C H CH3 OH. Just see to it clearly. Can you see? Once again I am writing what I am trying to tell you, kids, try to see COH and CH3 on oxidation, because I2 or any X2, you can take any X2, X2NaOH, where X should not be fluorine, there is no fluoroform test. So these are mild oxidizing agent, it will oxidize it. So these two hydrogens will eliminate out. Can you see? You will get R C double bond O CH3. This compound is having 3 acidic hydrogens. 1, 2, 3 acidic hydrogens. Now see what is going to happen. See to it carefully, right? X NaOH, you know that OH is a base, so it will start the reaction. It will snatch 1 proton from here, right? Acid base neutralization. Am I right? First thing, this is the starting acid base neutralization. Now this Na plus will snatch X negative, second reaction, and this X plus will go to this carbon ion. This will come over here. So in place of 1 H, it has got 1 X. Lost H, got X. See how it will look like. R C double bond O C H H, and in place of 1 H, it has got X. Now once again the same process will get repeated. It will come R C double bond O C H X, 1 more X. Once again reaction will get repeated. You will get now R C double bond O C X X trihalogenated. So X2NaOH X2NaOH. Now there is no acidic hydrogen, so what is going to happen? The OH negative now will act as nucleophile and will attack over here. What you will get? Now acting, till now it was acting as a base, but here it will act as nucleophile. You will get this compound, just see, R C O negative and this OH and carbon X. Now taking the support of 3X, this carbon will eliminate out as a negative. Now this negative charge can do back bonding with this X. Either 3P, 3D is vacant, or 4D is vacant, or 5D. But you know that 2D is not there, and that's why it cannot be fluorine, no fluoroform test. So it will RCOOH, that is CX3 negative, and now exchange of proton will take place. So it will give proton to this will form CHX3 haloform. This form Rexona, RCOO, Na or K. So this is haloform. Got it? So all the compounds which have been formed during this reaction, this alcohol will give test. What type of alcohols you can find out? this aldehyde or ketones will give this test. This monohalogenated aldehyde ketone, dihalogenated, trihalogenated. How is the mechanism, kids? Do let me know in the chat section. You got it, everyone? Is it clear? Is it clear to each and everyone, kids? Do let me know. Nadia Khan, Shanvik, Jyotish. Now let me tell you how to write down the products. How can you write down the products? That also I will tell you right now. Don't worry, kids. Organic compounds I will tell you later on. Organic compounds. Just let me tell you how to write down the products and the special compounds which will show haloform test. Then I will give you one break. Okay, kids? And in haloform test, the most important, do you know the most important in haloform test, who is being the most important? Most important is iodoform test. Why iodoform test is most important? Because iodoform is of yellow color. Yellow PPT. Now let me tell you how to write down the products. Okay, just see, if somebody has given you R C double bond O CH3 plus I2 NaOH, in place of I2 NaOH they can also give you, kids, NaOI. This can be also written as NaOI, sodium. Yes, hypohalous. Hypohalous, that means hypohalite, sodium hypohalite. Now this is R part. Make R part with this RCOONA, RCOONA plus yellow PPT of CHI3, yellow PPT, yellow papita, yellow dirty fellow, water plus NaI. Right? Water plus NaI. This is the way. Now let me show you. Let me show you. Suppose if they have given reaction like this, HCOCH3, CH3, COCH3, C6H5, COCH3. Its name is acetophenone. Remember that they can give the name also, acetophenone. So I2 NaOH. So what do you get, kids? What do you get? This is R part. Just remember R part. What is R part? Take R part, HCOONA, CH3, COONA, C6H5, COONA, got it, plus yellow PPT, salt and water. Got it, kids? Everyone clear? You know how to write down the product? Just to let me know in the chat. It has become simple or not? It has become simple or not, kids? Do let me know. Okay, once more. Okay, let me write down another product. I will explain it with the help of another one, right? Don't worry. Suppose they have given you this reactant CH3, CH2, CH2, C double bond O, CH3. Just remove this COCH3. Just remove this COCH3. Rest of the part is R. Rest of the part is R. That means this part is R. R part. So what you are supposed to do? This R part, CH3, CH2, CH2 and add COONA. I hope you got it. So this is the R part. To the R part add CONA, CONA, CONA. To the R part. This R part, to the R part add CONA. I hope you got it. Do let me know, everyone. You got it? Just to let me know, kids. Just to let me know you got it. Very good. Pooja Kirti. Yes, yes, you are right. I will. So, special compounds which give this test, let me write down, then I will give you a break, okay? Special compounds. One is lactic acid. Lactic acid is CH3, CHOH, COH. Pyruvic acid, CH3, C double bond O, COH. Pyruvaldehyde, CH3, C double bond O, CHO. So one more test and then I will give break, okay? One more distinguishing test, then I will give break. That is 2,4-DNP test. Now this test is given by almost all aldehyde and ketones. What happens in this test? Aldehyde or ketone is allowed to react with Brady's reagent. What is Brady's reagent? Brady's reagent is NH2 2,4-dinitrophenylhydrazine, 2,4-dinitrophenylhydrazine. So you will get R CH double bond NH Roy, either red or orange or yellow color. Roy color, either red or orange or yellow color. So one more test, kids, that is sodium bisulfite test. One sir, again and again one test. Sodium bisulfite test. You must have heard. This test is given by reactive aldehydes only or smaller ketones. This test is given by aliphatic reactive aldehyde and ketones. What happens in this? For example, if I take acetaldehyde, this is del negative, del positive, and if I react it NaHSO3 positive negative, then I will get CH3 CHOH SO3H. Now SO3H is acid. Acid will donate its proton and this proton will come over here. I think this is Na. This is Na. So Na will go over there. So it's a white PPT. It's a white PPT, and how the name will be written, that is $1 million question. So acetaldehyde and sodium bisulfite. So it is white PPT of acetaldehyde sodium bisulfite, and it's a reversible reaction. You can regain it also, right? It is used for purification also. Used for purification also. Used for purification also. So kids, let's take one break. What's the time right now? It's 2:09. So kids, will you come with full on energy? Do let me know in the chats. Everyone, just to let me know. Let's meet at 2:30, right? 2:30. Let's take one small break. Let's meet at 2:30 with full ATPs. So one small break. Let's meet at 2:30. Right? But come with maximum ATPs, kids. to put each and everything in your hippocampus, right kids? Now see my eyes. No sleep is there, right? For you people, I am awake. Thank you kids for your hearts. Wow, great. Great kids, really awesome. Kids, so ready? Just to let me know. Over here. So how's the Josh, kids? Do let me know. Baba is ready. Your Baba is ready, kids. Just to let me know, kids. I want to see some fire in the chat section. Yes, kids. I want to see some fire in the chat section. Do let me know. How is the Josh? I want to see the Josh. Very good, very good. So let's it go, let's it go, let's it go, let's it go. Okay. That's really fantastic. Now, so next reaction is very important reaction. This reaction holds a hell lot of weightage, kids. Its name is haloform test. Acid derivative, so carboxylic acid derivative, and this is very important reaction. Haloform, no, not haloform. Haloform, so we have done. We are going to deal with Hofmann bromamide degradation. Hofmann bromamide degradation reaction. Hofmann bromamide degradation reaction, it holds a hell lot of weightage, kids. Really very important reaction. 15 star. I would like to give 15 stars to this reaction because this reaction is very important. So how many stars should be given to this reaction? So the answer is 15 stars. Really 15 stars. So are you ready with full of Josh? Josh, how's the Josh? Josh is high. So let's it go. Just first of all see very simple label, then I will tell you in detail. Amides, primary amides RCONH2 when reacts with Br2 plus KOH. In place of Br2 KOH, they can give you KOBr also, right? Potassium hypobromite. Now this is being primary amide. Now remember that what should be the product? Product will be one carbon less primary amine. Plus side products like 2 ice of KBr plus K2CO3 plus water. Now, how to learn it? One song is there. Primary amide has been treated with cover. Everyone's primary amide has been treated with cover. We got primary amine with one carbon stolen, one carbon less. One carbon less. Everyone sing this song. Primary amide has been treated with cover. We got primary amine with one carbon stolen. So everyone singing this song? Are you singing this song? A primary amide has been treated with the cobra. We got primary amine with one carbon stolen. Kids, what's going on? What's going on? You're not singing this song. How will you learn this? How is the song? How is the song? Just to let me know. How is the song? Kishore Kumar spotted. Oh my God. Kushal is saying primary amide has been treated with the cover. We got primary amine with one carbon stolen. Thank you, thank you. That's nice, that's nice. Really nice, really nice. Now, how this reaction, suppose they are giving you acetamide, just see what product you will get. Acetamide. So acetamide is given, then you will write down this CO will eliminate out this CO, so you will get methylamine. Now benzamide they have given a, if they have given you benzamide, then once again just what you are supposed to do, remove this CO, you will get aniline, right? Now kids, this reaction's intermediates are super awesome and super important. Very, very important. Intermediates are very, very important. So remember the intermediates, see how the mechanism will proceed. Everyone just see the mechanism of this reaction, okay? RCO NH2, two acidic hydrogens. So Br2 KOH, if you see this reaction just like iodoform test, this OH negative will take away this one proton, negative charge. K positive will react with Br negative, and this Br negative will go over there. Then bromamide. First thing that you are going to get, that is bromamide, RC double bond O NHBr. Remember its name is bromamide. Its name is bromamide. Now this bromamide, once again OH negative will come. Sometimes they ask you how many KOH are utilized, how many KOH in NEET, right? So see, once again the K positive and OH negative will come. OH negative will try to steal this proton, then you will get anion of bromamide, the first intermediate. Anion of bromamide. Now K plus will come and take away this bromide. Now the most important intermediate you will get, RCON. Now in the first attempt it will look like nucleophile because there are two lone pairs, but actually it's electrophile. Why it's electrophile? See, nitrogen is only having 6 electrons, so it's electrophile. And what type of electrophile? Neutral electrophile, known as acyl nitrene. Main intermediate, this is electron deficient, only 6 electrons. Nitrogen is with only 6 electrons. Remember that. Now what is going to happen over here? This R, by taking electron, will switch to this nitrogen, and this is rate determining step, slowest step. So now how this carbon will get positive charge? Now R negative will donate 1 electron to this nitrogen. So once it is donating, how it will look like? C double bond O positive, nitrogen negative, and R. Now negative and positive, I think I missed something. Yes. No. R and C. Yeah, it will form a bond over here. It will form a bond. R and double bond C, double bond O. Remember that this will be known as isocyanate. Isocyanate. What do you call it? Isocyanate. Now, this will react with water. So this negative and this positive. So water's H plus will react over here, and OH will form a bond with this, right? OH will form bond over here, H with here. So what you will get? R NH C double bond OOH. This is known as carbamic acid. What do you call it? Carbamic acid. Now carbamic acid, from this carbon dioxide will get released, and this H plus will come to this nitrogen. So you will get RNH2 plus carbon dioxide will react with 2 moles of KOH, acid base neutralization, to form K2CO3. So total 4 moles of KOH. 4 moles of KOH are required to complete this reaction. And what are the intermediate names you have to remember? Let me tell you this on fresh page once again, so that you can remember each and everything. Okay, so this was the reaction. R CONH2 treated with Br2KOH. It has given RNH2. Now the intermediates, first intermediate was bromamide, then anion of bromamide, because they can start reaction from here also, right? Anion of bromamide, then acyl nitrene, then isocyanate, then carbamic acid, then 1 degree amine. This is the whole thing you have to remember, because all these things will be asked. Bromamide, everyone say bromamide, anion of bromamide, nitrene, isocyanate, very important. It's not isocyanate. They will give you isocyanate. Here isocyanate will not form. Isocyanate. Carbamic acid. Definitely they will ask this, and they will point out over here. Now let me tell you isocyanate story, and let me comparative study. Let me give you 3 things, very important, 3 things. Just see to it what I am going to tell you, so that you should not get confused during the examination. If I say Hoffman bromamide degradation, what we have used right now, RCONH2, and that has given RN double bond C double bond O isocyanate. I can say isocyanate, but if you do the reaction, that carbylamine reaction, just see carbylamine reaction. If you remember carbylamine reaction or test, RNH2 chloroform and KOH, then there you will get RNC. If you remember, kids, its name is isocyanate, that is isocyanate. This is isocyanate. See how much similarity. And one reaction is Hoffman mustard oil reaction, not given in NCERT but very, very important. Hoffman mustard oil reaction or test. In this, what happens? RNH2 plus HgCl2 plus CCl4 gives Rn double bond C double bond S isothiocyanate, and its pungency is like mustard oil. Its pungency is like mustard oil, and that's why people are adding it to palm oil, and they are selling it at the rate of mustard oil. Palm oil is 10 to 15 rupees per liter, but mustard oil, 400 to 500 rupees per liter. So this is comparative study. See, kids, it is mind blowing or not? Just to let me know it is mind blowing or not. I want to see in the chat section, it's really I have given the best thing or not. Do let me know in the chats. Do let me know in the chats. Yes, Sahana is saying yes. Prajwal ready? Just not, don't worry, it's right now, it's how, what's the time? 2:48, 1 hour more. I will complete each and everything just in 1 hour, right? 1 hour more, 1 hour more, okay? I want to see the fire in the chat. You are enjoying it. Ishika, very good. Very good. Just see your Baba is working. See, I am not leaving even a single line of NCERT. Whatever is not given NCERT, I am even giving you that also, whatever is required for your selection. That's fantastic, fantastic, kids, fantastic. Now, these reactions we have done. Now, let me tell you, kids, some more reactions which are important and which are very, very important for examination. So, let me write down that reaction. Reaction, I would like to say Rosenmund reaction. Have you ever heard this name, Rosenmund reaction? Have you ever heard the name of Rosenmund reaction? What's this reaction? RCOCl in presence of Lindlar's catalyst H2PD barium sulfate, H2PD barium sulfate, what do you get? RCHO. Remember that aldehyde is produced in this reaction. For example, if examiner has given you benzoyl chloride, Its name is benzoyl chloride. So with the same reagent you will get benzaldehyde. Remember that. What will you get? Benzaldehyde. Okay. Now, one more name reaction, very important, I would like to say, that is Reimer-Tiemann reaction. You must have heard the name of Reimer-Tiemann reaction. How many of you have heard the name of Reimer-Tiemann reaction, kids? Very important name reaction, Reimer-Tiemann reaction. Now, before I start this reaction, Reimer-Tiemann reaction, I would like to give one mind map where you can get all the reactions. Before this, I would like to give you one mind map where you will get most of the reactions. See the mind map. And you have to tell me that it's clearly visible or not. Visibility, you have to tell me. I'm starting from here, benzene. Benzene. I want to convert benzene into toluene. What should I use? You have to help me, kids. I want to convert benzene to toluene. Do let me know which reagent should I use, kids. Which reagent should I use? Tell me, kids, which reagent should I use? Definitely your answer will be methyl chloride anhydrous AlCl3. But if somebody is asking what the name of this reaction, what do you call it? Then this is known as Friedel-Crafts alkylation. Am I right, kids? But before I move ahead, do let me know, is it visible or not? Is it visible or not? Now, if somebody is saying how to convert toluene to benzyl chloride, how will you convert toluene to benzyl chloride? So, how will you convert toluene to benzyl chloride, kids? Then my answer will be that react with Cl2 H nu. But if somebody is asking what's the name of this reaction, so we will say free radical substitution reaction. Free radical substitution reaction, right? In short, we will say FRSR, free radical substitution reaction. Now somebody is saying that how will you convert benzyl chloride to benzyl alcohol? Benzyl chloride to benzyl alcohol. Now we have to use KOH aqueous. KOH aqueous. The name of this reaction will be nucleophilic substitution reaction, NSR. Before I move ahead, let me see in the chats what you say, kids. Visibility is properly, each and everything is visible or not. Do let me know in the chats. These compounds are visible or not. Are they visible or not, kids? Perfect. Sahana, thank you. Thank you. Chaitanya, thank you. Really thanks. I will give you each and everything, kids. This is for you. This is a gift. Otherwise, it's very costly. So, I think, yeah. Now, see, kids. Now, if I want to convert this benzyl alcohol to benzaldehyde, how I will convert it into benzaldehyde? Then the simple answer is that react it with PCC. I taught you this or not today? PCC is the best MOA. Best MOA. Now benzaldehyde, how to convert into benzoic acid? Now I will use SOA. SOA is strong oxidizing agent. Remember that KMNO4 acidic medium. This is being SOA and this was MOA. MOA means mild oxidizing agent. SOA is strong oxidizing agent. Try to keep it in your brain also, kids. Now benzoic acid reacted with let us suppose ammonia, then we will get ammonium benzoate. Now I will react it with ammonia, then I will get through acid base neutralization ammonium benzoate. Now if I heat it, what I will get? Strong heat. On strongly heating it, I will get benzamide with the loss of water. Benzamide is visible to all of you. Yes, it's visible now. Right now I told you that benzamide will get converted into aniline. How, kids? What should I do? Which type of reaction am I supposed to do? So definitely the answer is Hofmann bromamide reaction, Br2KOH. Now if somebody is asking how to convert benzene to aniline, then you have to go in the opposite direction. Do the nitration. You will get nitrobenzene, and then do the reduction. You will get aniline. So do nitration, then reduction with 10 HCl. One round circle is completed. You have to complete this round circle in your brain also. Then you will get full marks. Now you must be thinking that is it over? No, kids. Let me make it. What's a Lingesh? What's a doubt? Do let me know what's your doubt, Lingesh. Yeah, Afifa Sheikh, thank you. Others people, so only some people can understand this is this is the best gift. This mind map. Yeah, alkylation, if you do methylation, then yes. This is the tip to boost your marks. This is the only tip to boost your marks, kids. Now see. Let me fill it. Just see, if I want to convert it toluene to benzaldehyde in one step, if I want to go from toluene to benzaldehyde in a single step, how should I go? Then there is one reaction that is known as Ettard reaction, CrO2 Cl2 CCl4 H3O plus, Ettard reaction. Now if you do the side chain oxidation, if you do the side chain oxidation of toluene, you can reach to benzoic acid. How to do that side chain oxidation, kids? This you can do with KMNO4 KOH heat. You will get it. Now if you do the diazotization of aniline, what you will get, kids? Diazotization means NaNO2 HCl. You will get benzene diazonium chloride. Now, benzene diazonium chloride, you can make fluorobenzene with Williamson reaction. You can make chlorobenzene with Sandmeyer reaction. You can make cyanobenzene with CuCN, KCN. With cyanobenzene, you can go to benzoic acid, you can go to benzamide, and you can come to benzaldehyde also. See how. If you react with H2O2 OH negative, if you do the hydrolysis, H2O acidic medium, and this with SnCl2 HCl H3O plus Stephens reduction. Now kids, you can do the diazotization. Done diazotization, we have done coupling reaction. Now coupling reaction, see, benzene diazonium chloride on reaction with phenol. These are coupling reaction. Just remember that di, you will get di coupling reaction. Para-hydroxyazobenzene you will get. This is orange color dye. Orange dye. Now if you react it with aniline, you will get yellow dye. Now, benzene diazonium chloride, if you want to directly come to this benzene, how will you come to benzene, kids? Do the reaction, that is a redox reaction with H3PO2, that will give H3PO3 on oxidation, or ethyl alcohol, that will give you acetaldehyde. Redox reaction you will get. Now benzene diazonium chloride, if you treat benzene diazonium chloride with the boiling water, what will you get? Warm water. H2O heat, you will get phenol. Now this phenol on reaction with the zinc dust, you will get benzene, but phenol on reaction with chloroform, KOH, you will get salicyldehyde. If you treat it with CCl4 KOH, you will get salicylic acid. These two reactions are known as Reimer-Tiemann reaction, RTR. Let me check it out whether you are able to understand or not, kids. Just to let me know. It's visible or not to each and every one, kids? Do let me know, visibility is there or not, kids? Really, it's looking good. Really, it's looking good, kids. Wow, Lingesh, you are asking for Gattermann coach also, but the chart will, yes, I can go, but it will become a little bit confusing. Gaui Sankara Deve, wow. Everyone is saying thank you, sir, for my best revision. Wow. Really thanks, kids, that you are able to understand. This is really awesome. Fantastic, kids, fantastic. That's really awesome, kids. Yeah, today I will share it. Thank you, Sahana. Thank you, Pruthi Rajesh, Pooja Kirti. Now, let me clear it. Let me complete it. Now, this salicylic acid on reaction with acetic anhydride CH3 COCl will react over here and you will get aspirin. Aspirin is painkiller. Now this phenol on reaction with NaNO2HCl yellow colored para-nitrosophenol, yellow oily liquid, and this is also known as Lieberman's nitroso test. Otherwise, it is given by 2-degree amine. 2-degree amine, it is generally given by 2-degree amine, but this also gives. Now, kids, if you react this benzene with CH3COCl, that is Friedel-Crafts acylation, you will get acetophenone. Now, if you react this acetophenone with Cl2NaOH, you will get CHCl3, Br2NaOH, CHBr3, I2NaOH, you will get yellow PPT of CHI3. Now, kids, if you react it with silver powder, remember that all they will give one common thing. What's that? That is acetylene. Now, acetylene on polymerization, will give you benzene back on polymerization with red hot copper tube at 500 degrees Celsius. You will get benzene back. Now this aniline on reaction with chloroform KOH, you will get phenyl isocyanate, and this is known as carbohylamine reaction. Now this benzoic acid on reaction with PCl5, you will get benzoyl chloride, and this on reaction with H2PD barium sulfate Rosenmund reaction. You will get benzaldehyde. Now this benzaldehyde on reaction with concentrated KOH will show Cannizzaro reaction to give sodium benzoate plus benzyl alcohol, Cannizzaro reaction. So I hope kids you can understand this mind map. Thank you, Sahana. Kids, do let me know. Everyone, do let me know. All the reactions are getting covered in this. If you're really liking it, I want to see your likes, and hit the like button. Smash the like button. Those who have not smashed it. Ishika Kesharwani, thank you. Wow, really thanks, really. Hafifa Sheikh, thank you. Everyone, first of all, do let me know, Boosting Gaming, that it's clearly visible, each and everything is clearly visible or not. Thank you everyone. Really thanks for your liking. Wow. That's really awesome. Thank you. Now, after telling you all these things, yes, Janvi, it's really like that. It's like we have learned whole chemistry in one mind map. Oh yeah, that's really awesome that you can understand. That's really awesome, kids. Wow, Afifa Sheikh, really thank you. It's so much respect for your Baba HSP. Wow, I'm feeling really happy. I'm really feeling happy. Wow, Lingesh, thank you. Really thanks. Wow, Vishal MH, yeah, now. Great, great, great. Yeah, amines. Biomolecules we will do later on. Biomolecules we will do later on, but amines I will tell you. Amines I will tell you. Once this mind map is clear, now I am going to start the one mind map of acid carboxylic acid derivatives and then amines, right? And then near about up to 4 class will get over. Each and everything will get clear, right? So kids, now one mind map for carboxylic acid derivatives. Reduction, first mind map for reduction. Now reduction, see, if I write down here at this place, if I write down reactant here, the reagent or the product here, now H2 nickel, LiAlH4, ether, NaBH4 acid. So reactants are RCHO, first one, second is ketone, third is RCOCl, fourth is RCOOH, fifth is RCOOR, sixth is acid anhydride, seventh is RCH double bond CH R, eight, total 8, right? 1 2 1 2 3 4 5 6 7 8. What should be their products? Its product is primary alcohol RCH2OH. Its product is secondary alcohol, primary alcohol, primary alcohol, primary alcohol, primary alcohol. All they are primary alcohol except one, that is secondary alcohol. All right. Now these two are alkene and alkyne. So alkane RCH2, CH2R RCH2 R. Now who can, out of these three, who can do these work, right? So somebody asked this H2 nickel, how many works you can do? He said, hey, all the 8 works I'm able to do. I can convert all these reactants into these products. The reagent over here, these reagents, so they will convert all these work done by H2 nickel. So they asked LiLH4 what you can do. Yes, but these two I can't do. They asked NaBH4 how many work you can do. 1, 2, 3. Rest I won't be able to do. I can't do. So they said you are so much selective. Now see kids, this is one more mind map that reduction will help you. It's clear you got at one single place. You got these things at single place or not kids, just to let me know. Now I will give you one mind map for the carboxylic acid derivative. Okay kids, this is clear. Add RNO2 also. Oh my god, Lingis, you are so intelligent, huh? Lingis, you are really, what to say. Okay, let me write down reduction of nitrobenzene. Lingis, you are so good. Nitrobenzene reduction. Mind map for nitrobenzene reduction. This is your nitrobenzene kits. If you react this nitrobenzene with H2 nickel or tin HCl, you will get aniline, if you reacted with N-phenyl hydroxylamine, you will get with ammonium hydroxide. This is in acidic medium. This is in neutral medium. Now alkaline medium. Now there are 3 ways. 1, 2, 3. 6 nascent hydrogen, 8 nascent hydrogen, 10 nascent hydrogens. See, adioxybenzene, its name is adioxybenzene. This is azobenzene. This is hydroazobenzene. Now, electrolytic reduction. In 2016, they have asked electrolytic reduction. In slightly acidic and strongly acidic. Aniline, para-aminophenol. Now, one is selective reduction. Selective reduction. Two NO2s are there. Now with yellow ammonium sulfide. Yes, yellow ammonium sulfide. One NO2 will convert into NH2. Another NO2 will remain as such. Yes, is yellow ammonium sulfide. Is it clear? Let me see. Let me check. The chart is clear to all of you kids. Yeah, it's clearly visible. Fantastic. Great response by Sahana and all my dear students. Bepe, Shika Kesharwani, Jyotish, Ram Shah Sheikh, Afifa Sheikh, all my dear students. Hit the like button, make it 650. Those who are new, and if you have already smashed it, no problem, right? Boost Gaming, crystal clear. Wow, thank you, Lingesh. Now, very good. Janvi, thank you, really thank you. Now, let me give you बस हाफ आवर मोर, आधा घंटा, बस आधा घंटा चैतन्य, आधा घंटा और उसमें पूरा कवर अप हो जाएगा. बस एक एसिड डेरिवेटिव देना और एक अमीन्स कराना है, राइट? एसिड मीन्स acid derivative chart. Okay, now before giving you acid derivative chart, carboxylic acid, let me give you first carboxylic acid derivative chart, mind map for carboxylic acid derivative. See, acid halide, anhydride, ester, amide. Now this is the reactivity order. Now you will ask why this is the reactivity order. Definitely you will ask why this is the reactivity order. This is the reactivity order towards water and towards NSR, towards ESR also. Water, NSR and ESR. Now you will definitely ask why. You know that leaving group tendency. If you eliminate out X negative, if you eliminate out this whole negative leaving group, eliminate out this and eliminate out this. So stronger bases are good leaving group and weaker bases are poor leaving group. So this is X negative, and if you add H to the X negative, it will become HX acid, and stronger acid conjugate bases good leaving groups. Leaving group tendency. So it is based on reactivity is based on leaving group tendency. Let me show you so that everyone can understand. This is HCl, HF like that, and this will become RCOH. So weaker than this. Then ROH is alcohol, even weaker than that, and ammonia. So the acidic strength is in this order. Acidic strength is in this order, right? So stronger acids conjugate bases, weaker base, and weaker bases are good leaving group, right? Got it? Weaker bases are good leaving group. Now that means if you react this with the water, immediately you will get carboxylic acid. Even in cold water, the reaction will take place and you will get carboxylic acid. This will react with normal water. This will require hot water, and this will require some acid or base along with water, otherwise reaction will not take place. Now how to go back? Just see, if I want to get this from that, you can use PCl5. If you are using PCl5, side product will be POCl3 and HCl, or you can use PCl3, then side product will be H3 PO3, or you can use thionyl chloride, then the side product will be SO2 HCl. Now if you want to get anhydride, then you have to eliminate out water, and that is you can use P4O10, right? Now ester you want to use H2SO4. with this you will get ester, alcohol plus acid, H2SO4. Now amide you want to get, then its process is little bit lengthy. First you use ammonia and then strong heating. Now I hope this is clear. This is clear to each and everyone. Now do let me know. Let me see the chat section, it's clear or not. Do let me know, kids, is this clear or not? Do let me know, kids. Reimer-Tiemann, yeah, Reimer-Tiemann, I will tell you. This much is clear to each and every one of you kids. Do let me know. Wow, thank you. Now, let me give you memory chart for amines. Now I am switching towards amine kits. Okay, amines memory chart. I am going to give you amines memory chart. Just see. This is 2 carbon primary amine. Now I want to grow up this primary amine. Let's see how to grow up or how to degrade. Remember that this will not react with anything except HNO2. How to get HNO2? NaNO2 dilute HCl. You will get HNO2. So this will convert aliphatic amine into alcohol directly. Remember that. Amine will convert to alcohol directly in single step. Now, this alcohol react with phenyl chloride. You will get CH3, CH2, Cl. Now react with KCN. KCN, ambidentate nucleophiles, CH3, CH2, Cn. Now, by any of these 3 methods, you can change to, first method is sodium amalgam ethyl alcohol ETOH. This reaction is known as what? Mendius. You will get this product, or H2 nickel you can use, or LiAlH4, this you can use. So increased from 2 carbon to 3 carbon. You see here 2 carbons only, here 3 carbons. Now if you want back from 3 carbon to 2 carbon, you can do that. In all the 3 processes you will get same thing, right? Now once again you react it with HNO2. Once again you will get alcohol. Now do the oxidation, and then you will get CH3. Now react with ammonia and heat, then you will get amide. Now do the happy body reaction of this. What will you get, kids? So ascend of series and descend of series. How it is, kids? You can do any conversion from this, the ascend of series and descend of series. You can do any question, kids. Any question. Are you getting my point, kids? Do let me know. Just 20 minutes more, kids. Each and everything will get over. 20 minutes more. Now, kids. Any reaction? Thank you, Janvi. Thank you. Any reaction do you think? Yeah, Soumya. Yeah, 18 minutes left. Anything you think? Now, let me tell you. The name reaction. Any name reaction are you thinking which is left, kids? Do you think any name reaction? No. In these minutes, let me tell you the main thing from biomolecules which can be asked. Okay, we have gone through each and everything. Now let me tell you the biomolecules. The most important thing from biomolecules, that first thing, very important thing which is missing in NCERT but very important for examination, missing in NCERT missing part. What's the missing part? That is ozone formation. It's very important for exam. What is ozone? Yellow crystalline solid. Now how this will get formed? What happens? So in shortcut, if I say that glucose or fructose or mannose, either of these three, if you react with 3 moles of phenylhydrazine, 3 moles of phenylhydrazine, will form this product ozone, Now let's see how it will get formed, because in detail they can ask. Okay, just see to it. This is your glucose, rest of the carbons I can take as R. So this is glucose. Just focus. Now react it with phenylhydrazine, kits. C6H5 NH NH2 This is phenylhydrazine, so it will react. Water will eliminate out, right? So what you will get? Glucose will convert into yes, glucose will convert into what? What do you call it, kids? Glucose phenylhydrazone. Glucose phenylhydrazone, right? Now once again phenylhydrazine will come, kids. C6H5 NH NH2. Now how the reaction will take place? See, kids, this will take this hydrogen and will eliminate out as ammonia. Ammonia will get eliminated. Now this will take this hydrogen and will form aniline. Remember that. Number of times they have asked this question. The side product, water, ammonia and aniline are the side products. Now you will get CH double bond N NH C6H5 C double bond O R. Now once again 1 more mole of phenylhydrazine will come, kids. C6H5 NH NH2, and that will eliminate out your water. Now what you will get, kids? You will get CH double bond N NH C6H5 C double bond N NH C6H5R. Now it can't react further because this is only yellow crystalline solid, because we have formed it from glucose, so its name is glucosazone also. Glucosazone, or you can call it osazone, or you can call it dihydrazone. Remember that, 2 times, 1 times hydrazone, second dihydrazone. Fructose also will form it in this way only, fructose. Now this is clear. Let me see the chat section, kids. Is this much clear? Then I will tell you next thing, kids. Is it clear? Clearly visible to all of you, kids? Do let me know. And those who have joined right now, smash the like button, kids. Those who have joined right now, smash the like button. Very good. Now see, kids. Now let me tell you in this chapter rest of the things, that if you see the glucose, so if you react glucose with HI, red phosphorus, so what HI will do? It will convert all the OH into H2, CH2, and CHO also into CH3. So you will get N-hexane. What will you get? N-hexane. If you react glucose with hydrogen cyanide, you will get glucose cyanohydrin. If you react glucose with NaBH4, reduction will take place. You will get compound like this, and this compound's name is what? Sorbitol, remedy for diabetic patients. Sorbitol, remember that, what? Sorbitol, a remedy for diabetic patients. Let me have a sip of water, kids. Now, if you react glucose with toluenes, phthalates, reagent, what do you get, kids? With toluenes you will get silver mirror, phthalates you will get which color? With toluenes you will get silver mirror, with phthalates you will get red color. With the bromine water will get decolorized and you will get gluconic acid. With concentrated HNO3 you will get glucaric acid. There conic acid here, glucaric acid, also known as saccharic acid. How it looks? COOH, CHOH whole 4, COOH, saccharic acid, right, kids? But remember that one thing about glucose, glucose doesn't give SSB. What is the meaning of that? Glucose doesn't give SSB, very, very important. The meaning of this is it doesn't give SSB. What should I say? Meaning of this? B for Brady's test. That's why I have told you that time almost all the reaction it gives. Brady's test, sodium bisulfite test, SIPS test. These three tests, glucose will not give kits. Then how will you distinguish in between glucose and fructose? That's a $1 million question. Do let me know, kids. Till now it's clear? Till now everything is clear? Yes. Till now everything is clear. How will you distinguish in between glucose and fructose? That is a $1 million question. So glucose and fructose both give positive Tollens and Fellings test. So this cannot be used as a distinguishing test. So therefore, they are distinguished by bromine water test. Remember that bromine water test, kids. Now, one more thing, most important. Maltose is made up of, means on hydrolysis it will give what? Alpha D glucose plus beta D maltose, 2 moles of alpha D glucose, 2 moles. Am I right, kids? But if you talk about lactose, anyone can do, let me know. Lactose will give what? Beta D. Beta D. What beta D? Beta D, galactose and beta D glucose. Remember that. Both are made up of 1,4-glycosidic linkage. Now, cane sugar is made up of, that means sucrose. The starting two gives what? Reducing sugars. So they will show mutarotation. This is non-reducing sugar. Will not show mutarotation. So sucrose on reaction with water in presence of enzyme sucrase, that is on maltase. This is on lactase enzyme. This is on invertase, also known as sucrase. So we'll give alpha D glucose, beta D fructose. Kids, let me check it out. What's the time? Oh yes, we have done it, kids. We have completed. And today's the fantastic thing is, the most awesome thing is what? Out of these many memory charts, I have given to you, which memory chart is the best one? I think this one. This one is today's awesome gift. Do let me know, kids. This one is today's awesome gift. So what you will say, kids? Really, your teacher is hardworking. I've moved through the sequence. I've completed each and everything or not. Do let me know, kids. I want to see that really I have completed each and everything. Oh my God, thank you. So once you wake up in the morning, I want to see the comments. Thank you, Nighty Spidey. Sir, every single thing you gave us a awesome gift. Wow, kids. Sahana, Ishika Kesharwani, Janvi, Madhuliha, still awake, kids. Lingesh. It feels incomplete without the Gattermann coach. Okay. Lingesh, let me complete. I can't wait. Lingesh is saying so. Let me complete. Lingesh, ख्वाहिश पूरी हो जाए. Lingesh ji, see which color. I will use this color. Okay. So see, kids, as Lingesh said, let me. Oh. Where it's gone, kids? Yeah, it's over here. So let me move Gattermann coach and Gattermann aldehyde. Okay. Gattermann coach, Gattermann aldehyde, C. Okay, Lingesh, now it's okay. Lingesh ji, now it is okay. Do let me know in the chat. Now is it okay? Okay. Yes. Reimer-Tiemann reaction. She is right. So just wait for 2 minutes, kids, everyone. Otherwise, in the memory chart I have given, but let me tell you there also, because heading I have added. So let me complete here also. Phenol CHCl3 plus KOH, both together will produce attacking agent dichlorocarbon. Remember that this is the attacking agent. Dichlorocarbon is the actual attacking agent, kids. We will get salicylaldehyde. And if it is treated with we will get salicylic acid. Now with memory of this reaction, I would like to tell you one more reaction, kids. That reaction's name is Kolbe's reaction. Kolbe. Kolbe's electrolysis, I have told you, this is only Kolbe reaction. What's that? Phenol on reaction with NaOH, sodium phenoxide, you will get carbon dioxide and pressure and hydrolysis, you will get salicylic acid. So this also I have told you. Now I will stop over here only because this is the best memory map. So this is over and out, kids. Sorry because I have gone there. So I would like to say God bless you, kids. Love you, kids. Really thanks, kids. Really thanks. May Almighty God bless you with all happiness and prosperity, kids. You should get all the best. Afifa Sheikh, Ishika Kesharwani, and thanks for this much of respect, giving this much of respect to Baba HSP. So hey kids, really thanks a lot kids. And let me show you this and then the pose. Hey, yes, really thanks for this. And kids, this is the awesome memory chart. If you want to take the pic, your Baba is giving the pose. Yes. Have you taken kids? Have you taken the pic? Bye to all of you. Thank you. Go and sleep whenever you wake up in the morning. Janvi, thank you. Boost Gaming, thank you. Whenever you wake up in the morning and get time, then comment over there. I will give written reply, right? Wow, Casper, Sanju, Bhavana, wow, Bhavana. Thank you, kids. Now go and take a sound sleep. Bye to all of you. God bless you. Love you, kids. Thank you, kids. Thanks. Really thanks, kids. Bye, kids. Chaitanya, bye. Thank you, Chaitanya. Lingesh, bye. Thank you. Yes, Sahana, yes. Thank you. Yes, yes, Chaitanya. Thank you. Sure, sure, Chaitanya. Chaitanya, sure, sure, and thank you. Thank you, Chaitanya. Casper, thank you. Thank you, Casper. Thank you. Thank you, Afifa Sheikh. Thank you. Thank you. Really, thanks. Shivelo, bye, 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 kids. Take care. Yes, Sahana, yes. Thank you. I will take dinner. Jaipur, Jaipur. I'm taking classes from Jaipur right now at the studio. Jaipur offline. Yes, Chaitanya. Sure, sure. Take care. Thank you, Casper. Thank you.